Roxra, Keo, and Snazzy, hello. Keo, it's been a minute. I hope that you've been well. Glad to see you again. Benluck snipes the first though. Making sure I don't get tricked by the audio levels for the song or for the music. I think that'll be a good volume. Usually you're last. Okay. Rowdy. That's true. We should get an Esker run going. Yeah, the freaking I played the Lucky server once and it's generally fine, but it had a couple of like really bad lag spikes which were super annoying. But Zero just like released an Esker server too, and that would be like that's the classic that we like spent so much time on, so we should definitely get something going there. I know. For people who are watching my stream, like when I very first started, me and Rowdy spent a lot of time just playing at Esker. Those are like the old days. 2 weeks of the summer semester, you need it to end already. Oh, you're almost there, Snazzy. Summer classes are always like harder because they're so much like faster. Close to finishing your EF core course for C#. Making database in SQL Server is annoying. It's so technical in C#. I didn't know people did that in C#. The clip, the one with the tripwire, Rowdy? That's all that comes to mind immediately. Yeah. Ugh. Okay, I promise I will get to the math in a second. But I'm kind of feeling nostalgic, and I want to see if I can find it too. I might have made it a short on my YouTube channel. That's what I want to see. I probably did. I don't remember if I did though. But yeah, unless someone asks me a question, we're gonna be doing more puzzles. Channel's kind of dead. I haven't done anything with it in a long time, but yeah, it's this one. Oh, ew. Why do I have that there? Oh, it's not even accurate anymore. I changed my name. Dude, this was such a funny moment. Dude, these auto captions too. How do I turn them off? Oh my god. Just a random tripwire. Yeah, I found it eventually. Oh man. Oh, you know we had a key card too. We were gonna go into the bunker. You were dead, yeah. I know. I really wish I knew who did it, because I respect whoever did. I remember the exact place where it happened too. It wasn't even like that close to the airfield. I think I'm on number 18. Um, just bringing it in. Oops. Yeah, ready. I'm definitely down to play over the week though. Pen, it's going good. How about you, dude? Always good to see you. You call 43? I don't even know what a blank is. I remember reading this question last time I streamed, and I could not stop thinking about, like, what the hell is a blank? That is made from lead blanks in a lathe shop. Each blank suffices for one item. Lead shavings accumulated from making 6 items can be melted and made into a blank. How many items can be made from 36 blanks? You call 42? That is the answer to everything. Each blank suffices for one item. We have 36 blanks. Oh, Fembox. I think I see why you're saying it's 43. Okay, so each of these 36 blanks gives us one item. But then 1/6 of those are like, we divide it by 6, and that's how many extra items we get from the shavings. But this number here is 6. So we get a 6 of that also. And I think that's where Fembox is getting 43. I guess I don't see why not. Let's see what. Let's see if the answer in the back of the book says that. So I want to verify it. 18. This text for ants. Lead shavings are enough to make 6 blanks. Which makes 6 more items. Don't stop here. New shavings are good for one more item. Total 43. There we go. Fembox only needed like 10 seconds to figure that out. Yeah, it would have gotten me too, I think. Okay. Arranging flags. Me, actually, I'll bring it to Journal++. Oh, crap. Make it smaller. Okay. Komsomol Youths has built a small hydroelectric powerhouse. Preparing for its opening, young communist boys and girls are decorating the powerhouse. This really is a Moscow problem. On all 4 sides with garlands, electric bulbs, and small flags. There are 12 flags. As they arrange the flags 4 to a side, as shown, but then they see the flags be arranged 5 or even 6 to a side. How? They have 12 flags. Huh. The powerhouse on all 4 sides. So this is just the building, I guess? Is this rectangle? This is... What a weird problem this is. Okay, so despite... If you have 12 flags and 4 sides to cover, you could definitely get like 3 flags on each side, which is like the even simpler case than they've drawn here. And if you're clever and put flags on each corner, these kind of count as double, so you could get 4 flags to a side. Apparently we get 5 or even 6 to a side. I assume we can't do the inside corners, can we? If it's 6 to a side, that would, and we only have 12 flags, you're somehow getting like 6 flags all in one corner. 6 flags. And then another 6 flags all in the other corner. That's the only way you can get 6 to a side, right? That does sound very communist. All sides get the same flags. Yeah. Can 2 flag posts meet at the corner? That's what I feel like there's no other way, Peach Tea. Like, it has to be the answer. They don't say you can't, I don't think. Two flags on the same post. Oh. Yeah, 5 to a side. What would that be like? If we just have 2 flags on all the corners, that takes away 8 of our flags. Oh, okay, yeah, this is the 5 to a side. You have 2 on all the corners, I guess. This feels like a rug, the way I lazily drew it. A lot of red flags. Especially... Wait. Yeah, the Soviet Russia flag is red, right? The hammer and sickle is gold or yellow, I think. Two times 4 plus 4. I feel like they're gonna say some super weird answer, but I guess like this is how you get 5 to a side, and that's, and I don't know whether we're like putting them on the same corner, or as Penvox said, if it's just like one long fence pole with multiple flags. But I guess those are kind of equivalent for this problem. Hey, Dessen. Or can we do, I guess we want 6 to a side. We could do just 3 on each corner. But there's 2 options. You could do 3 in each corner, or you could do 6 on just 2 corners. 4, 5, 6. Your answer is now our answer, comrade. All right, I guess I'm gonna look at the answer. This one's kind of weird. Oh, you do just stick them all on the same corner. Okay. I'm trying not to look at the answer for the next one. That's kind of a lame... I disagree that this problem is amusing. Seemed a little like overly simple. Oh, I did see something about it in abstract algebra class from Penn Center, or Penn Center is like helping out with. With the one to the exactly, Femvox. You know what? Just the last time I streamed, Penn, I was opening up that same Galleon textbook that you were using like maybe 2 years ago. Because Desmond was trying to get me to do abstract algebra, and I was failing at it, but it was kind of cool to like go back through it again a little bit. Next one is another corner one. I haven't read it yet. Let's see. In a rectangular dance hall, how do you place 10 chairs along the wall so there are an equal number of chairs along each wall? Maybe. Hang out in the lakes region of the UK, lurking a bit. Ooh, enjoy, Obi. Um, 10 chairs along the walls, so an equal... It's a rectangular dance hall. So, okay, the issue is we have 10 chairs and 4 walls, and 4 doesn't go into 10. And so, yeah, Peach Tea, I think like, surely it's a corner problem. Then we have 8 left to distribute, so we can do 2 on each wall? This is, again, very communist to ensure that each wall gets the same number of chairs. Like you just kind of put them around randomly in an actual dance hall. Yeah, I guess that's my answer. Where these chairs are doing double duty. Communist math, yeah. Da. all numbers equal each other. Keep it even. Take 16 objects, put them in 4 rows of 4 each, remove 6, leaving an even number of objects in each row and each column. There are many solutions. Okay. I think I already see one. Is that Doc Comrade? I'm just guessing. It is? Nice. 70s Russian physics textbooks? That would be interesting. I feel like they'd be... I imagine it was being very hardcore. So this was my first thought. Because they don't have to all be the same number, right? We just need an even number in each row in each column. And I think taking those 6 out accomplishes that. Wait, I feel like aren't there... Isn't this really easy? Like, you could also do this. My last 2... Oh, okay, fair. Oh, yeah, and okay, these 2 rows don't work now. Okay, never mind. Leave it to the Sudoku person to spot that. Okay, they don't all have to be adjacent either. We could do... What could we do? If we did, like, something weird, like... No, that doesn't work. Like you're doing a Sudoku right now. What if we get rid of the corners? And then what? No, not the corners. Hmm. Okay, this is a lot harder than I thought it'd be. Wait, oh, Who has 16 plums laying around? What is this author's life? You do? Maybe I'm living life wrong. I don't think I've ever actually eaten a plum. Plum? Maybe I have. I don't remember. Uh, does each mean every? You can have a 3x3 and then a one. Oh, you want to do this. I think this is the opposite of what we want. Equal here, every row and every column has an odd number, but it's kind of funny that's possible. Like we solved the inverse of the puzzle, or you have. But yeah, I think the problem is like this column only has one thing, this row only has one thing, and then all of these rows each have three things. Sometimes solving the reverse of a puzzle is like helpful in solving it. Plums are nice. They're almost like peaches, but better. Okay. Grandfather had a plum tree. They're so good. The ones at the store are different. Dude, that's always true with produce. It's so annoying. I would love to grow my own stuff one day. How come applying math to the real world is hard? I don't... Famished. Because the real world is complicated and messy, and it doesn't give you answers. It just gives you problems. Or did math runs that we just ate them? Apparently you were missing out, Silu. Echo, I have problems with reading the first like half of a sentence and thinking that I know what the second half is going to say, so why bother? And then I end up solving the wrong problem. I've done that way too often. I might have randomly bought plums at the store once. That's something I can't be sure of. But I don't know. A lot of produce at the store is just, like, it's just not as good as if it's like grown locally. Applications part of my math study since you've been skipping them. Fair enough. Applications are fun, even if they're hard. Thanks for the follow, Echo. Okay, I think... What... let's just start by doing something weird and seeing if we can make it work. What if I take out these? Hey, Arad. Reach for joy and all else will follow. That's a great fortune. I like that fortune. What if I remove... What is this? Oh, wait. No, never mind. This doesn't work. That was your first tactic, Peach Tea? You see a solution? If you're able to describe it, please do. Heidi Lau and other restaurants have smoked plum juice. It's perhaps an acquired taste, but really good. They also have pork brains. Oh, God. I never felt the urge to eat a brain before. Reading rows and columns, you can just start moving top left corner. That's true. This is like a very symmetric kind of situation. Lever poche? What is that? Oh, liver pate. I guess I should try it if I had the opportunity to. It's I'm not big on eating organs in general, I guess. I barely ever have. You grew up on it? They have a very weird taste compared to normal meat. Like, I forget, I think I ate, I forget which organ it was, but I ate some like chicken organ in Japan without realizing it, and it tasted super weird. Awful? Oh, I've heard of that. I can't remember what it is though. Let me Google that. Oh, okay. It's just organs in general. Okay. 0001. I don't know. I guess I'm assuming the what you're. Oh, okay. Either way, it doesn't really matter where we place the origin. No, this row is bad. Actually, yeah, and this column too. Oh wait, no, I'm misinterpreting you. You're not doing these. You're doing these. Oh, that works. Yeah, this is a solution. Nice. Um, Brazil is big into chicken hearts. Ooh, interesting. You eaten brain before? Famous. It was tasty. Ooh, geez. I don't know. I guess I'd probably try it, but not Chris. Let me see what you did. Oh, for P equals NP. Yep. P, you just rotate the N, smash it onto the P, and you have P equals NP for sure. Took my girlfriend to an orchard for her birthday. We stood there for 10 minutes. It was not the Apple Watch she wanted. Ugh, the Apple Watch. Nice G Hive. There are many solutions. Okay, I want to look at the answer for this one. So I wonder what other patterns you can do. Also, I want to see what they did for 10 chairs. Oh wait, oh yeah, and so Dustin, I saw you said earlier, could I check out your favorite proof book? I don't know if I want to do problems from like I'm doing with this, but okay, the 10 chairs is what I thought it would be. Um, oh yeah, these are different solutions. They use plums. Why? That's so random. This is a weird one. This one makes me uncomfortable with how like random it feels. I've never seen triple equality. This be exactly one row and one column left undisturbed. Ooh, interesting, Fembox. I think they did all have that in common. Seeing a bunch of weird knight moves. So like things like that. That's what PhD is seeing. Yeah, if we go by the Fembox principle and leave this row undisturbed, that row undisturbed, we could remove I guess that, and that's another solution. Yeah, like you could move it in a lot of places. English typed languages triple equals better test. Interesting. To remove either 0, 2, or 4 from each row / column. The JavaScript Holy Trinity mean? I don't think I do. For a single row / column can't work, and you have to remove at least 4 more objects. Yeah. Which languages are typed confused? Often IDs offer an editor type checking to convenience. Yeah, I really dislike languages that don't have explicit typing. Like, I feel really uncomfortable when I'm just saying x equals 2 and not int x equals 2 or something. So want to make a PP joke? PP jokes are always allowed. Wondering if 0 would count it in the beginning. I guess it would, but that would require you to remove an entire row or column, which will put you in an unwinnable situation. Okay. I guess I'll bring in the next one. A magic triangle. This is no ordinary triangle. And if anyone has a question or thing they want to like chat about, please do let me know. It's just something we're doing to kind of fill in the time while we wait to see if there's a question from chat. Python duck typing, everything just held together with string. It really is ickle. Like, I've gotten used to writing code in Python, but it still feels disgusting to, like, I don't know, I just feel like something is going to get messed up without me realizing it, without, like, me controlling the data types. I don't trust Python to do it right. One of loosely typed is it allows people to author type conventions specific to their app. That's not a great reason it's applicable to every lang. Yeah. Yeah, a part of it is I just learned to program with Java and C++. And so I'm used to having to do things like the hard way, even though that's not even as hard as you can make it on yourself, but I just don't trust like higher level languages to do what I'm telling them to, I guess. Like a rebellious teenager. I have placed the numbers 1, 2, and 3 at the vertices of a triangle. Arrange 4, 5, 6, 7, 8, and 9 along the sides of the triangle so that the numbers along each side add to 17. This is hard without being told which numbers to place at the vertices. Oh, okay, that's in the evolution. Let's start with the first part. 4, 5, 6, 7, 8, 9. Well, I guess the first thing I want to do is try, like, do the highest with the lowest as pairs. How far? Hey, 6, 7. C is loosely typed in its own special way, like with pointers? You're dealing with memory management too. Yeah. I mean, you don't have to use pointers in at least in C++ if you don't want to, but you can do some fun tricks with them. Now swap 4 and 5. Okay, wait. Let me I just want to add up these sides and see how far off I am. And then I'll swap them. We have 5, 14, 16, 7, what is 7 plus 8? 15. No, wait. Yes, 15. 18. And this is 1, 7, 14, 17. Oh, okay. And so yeah, swapping 4 and 5 is the perfect thing, Femvox. Because it adds one to this side, subtracts one from that side, and we get 17s all around. Papador, you join, the first thing you hear is 6, 7. You should see when the type system gets in the way of accessing something I know is in a byte offset array. I mean, I don't know what a byte offset. Oh wait, byte offset away. Oh, I see what you're saying now. Okay, that's fair enough. I think they do have like a null data type or something, right? I don't know. Six, 7. I got it, Dessen. I don't like. Just want me to like look at it. I don't. I if I'm just gonna be doing random problems, I'd rather do these puzzles. But I'm gonna see what's up with this book, or like what kind of textbook it is. Ooh, these are lectures? Hmm. Symmetry is always fun. I'll show the cover again. This is apparently Destin's favorite proof book. You have a book by him? Cool, cool. I just kind of want to scroll through. So I wonder if he actually gave these as lectures and wrote them down after, or like. I think they're called lectures and not chapters. The subway love triangle. Anne has 2 boyfriends, Bert and Kurt. The men demand she choose between them. Wow. See, this is a realistic math problem. Every good textbook Sarf has lecture notes. That's true. Proposes to randomly show up at her station every day for a month and take the first train that comes. Whichever boyfriend she visits the most. I feel like this isn't a very good way to choose a boyfriend. Get your hands dirty. There's no way to approach the problem without sitting on. Oh, I thought they were going to say to actually get 2 boyfriends and ride the subway to see them. Magic Square. Oh, was this like a the math magic type of show? I'll scroll this a bit more just to see like what the style this is. It does look kind of unique though. The Art and Craft problem song that I have, I guess they made it into one of the great courses lecture series. Okay, okay. Rows, columns, diagonals, and quadrants all sum the same. Right, yeah, I've seen those before. Prove there is no smallest positive real number. You know, oh, I guess you just always divide it. You assume there is a smallest positive real number, then you just divide it in half. And you have a new smallest positive real number. The evil wizard hat problem? Oh god, okay, that's too long for me to want to read, although that is a little intriguing. Okay, this might actually be kind of fun to look through at some point. I'm gonna stick with Moscow puzzles for now, though. Ben frankly made an 8x8 magic square, but just rows and columns. Even squares are hard. AF. There's an easy algorithm for odd squares. I didn't know that. Yeah, it's like a magic. It is a magic triangle, I guess. Okay, so what's the harder version of this? Without being told which numbers to place at the vertices, make it similar to numbers 1 through 9, adding to 20 along each side. So 1 through 3 are no longer fixed. Are there different things that we can make this sum to, by the way? Like, does it have to be 17? I don't know. So we need to place some higher numbers on the corners. Yeah, Femvox. That's exactly where I was. Actually, is that exactly where I was thinking? Or sorry, now the corners sum to 6. I don't know if that's the way to think about it, though. This is probably a good first attempt. And then let's try the same thing where, like, the lowest numbers on the corners get the highest available, well, the highest and the lowest, I said, but I guess let's do 9 and 1. Wait. 2 and 8. And then 3 and 7. And let's see how far this gets us. 10, 19. Almost. 10, 11, 21. Wow, this is going to be the same thing, is it? 10, 10 is 20. So we just swap, like... we probably do either, right? The 2 and the 1 or the 9 and the 8? I guess I'll do the 9 and the 8, because why not? Wait. Didn't I just make it worse? I think I need to do the 2 and the 1. There we go. So that'll be 20. And that'll be 20. Okay. Wasn't that much harder. Yeah, I don't know if there's a good way of, like, doing it without guessing and checking. So that's pretty much what I just did there. Oh god, I just saw Dessen post a problem in the Discord. Alright, let's see. Show if f is an entire function such that f of every complex number, or the set, basically the range of f, intersecting with the positive real axis is the empty set. So our function f never maps to a positive real number, is what this statement is saying. Then f is a constant. Really? Sum of 1 to 9 is 45. 3 sides of 20 make 60. So we need the vertices to sum to 60 minus 45. Oh, and that is 15. The sum of 1 to 9 is 45. 3 sides of 20 make 60. I'm still not sure why that's true. It does seem to be true, but that doesn't make sense to me yet. Can you get some conformal mapping and then use Liouville's theorem? Destin did say this is going to involve Liouville's. I'm not sure what kind of conformal mapping we want. That's kind of weird to me. This is enough to say that f is a constant. Every bounded entire function must be constant. So we want to show that somehow implies that f is bounded. If we want to use Liouville's theorem. Picard's little theorem, which says that every entire function whose image omits 2 or more complex numbers must be constant. Really? So we're not gonna, this would just answer the question for us immediately, but we're not gonna use that. That's so strange, though. The Great Picard theorem? Is that on this page? No? Okay, let me Google it. How great is this theorem? If an analytic function has an essential singularity at point W, then on any punctured neighborhood of W, fc takes on all possible complex values, with at most a single exception infinitely often. Oh, sure, for an essential singularity. I don't think this helps us, though, does it, Papadoria? One plus 2 plus 3 plus 9 plus v1 plus v2 plus v3 equals 20 plus 20 plus 20. 2 ways to add up all the sides of the triangle. Oh! I guess so, Fembox. Not saying they're dense takes on everything. Yeah, I've seen this idea before. It's like it's like oscillations. It doesn't help you. Sub Picard's little theorem. You're doing some great. Oh, you did post about that. Yeah, yeah. I forgot about that. It's a little more general. Okay. Yeah. Um. So same. We want to get to this thing being bounded. It's an entire function. And it never maps to the positive real line. My, like, I don't know if this will be helpful, but like, I guess the natural thing to me would be to start by naming 2 points in C and thinking about f of z2 minus f of z1 and trying to bound this in some way. But all we know about these two numbers is that they're not positive real numbers. We don't know anything else. Hmm. Think about the branch cut of logs. I could? Um, it's not entire. We could restrict theta. But then it's, well, I mean, that's going to be entire though, right? I don't know. We can define some h of z to be square f of z minus 1. Some continuous branch with a square root. Hmm. Branch cuts of logs. Like, would we take log of f? Um, oops. I I don't know. we could think about a power series. Element could be nicer. I don't think any of your questions have been nice. Let's see. Use a connected domain in C. H of Z be a harmonic function in U. Let F U to U be a holomorphic function. Prove that H of F is a harmonic function in U. Aren't harmonic and holomorphic the same thing? Like they imply each other? The phrasing of this question is kind of weird to me. I would think you'd do it with like limits. Like okay, for this notation, F is the outside function. Like this is backwards, right? From it's like F of H of Z. Like if we could show that this limit is well defined, I guess that would be enough. Cold gold. I was thinking about the one on top, and then I gave up, and then Destin posted this one instead. I don't think I can do this one either though, but I'm at least trying to think about it. So I'm looking at right now I'm looking at this one here. Hey Quant. You want to ask something? You're able to understand concepts easily, but practice is important. Yeah, practice is really important. There's a difference between understanding a concept and being able to like use it. So I would say you really do need practice too. Holomorphic implies harmonic, but harmonic does not imply holomorphic. I don't know. I thought it was an if and only if, but I never actually learned like the formal definitions. Yeah, it doesn't. I'm sorry. Your definition of easy is not the same definition. It's like not the same as mine. I have no clue what to do for any of these problems. I think I'm just gonna go back to doing my puzzles. I don't know what Chenglu is. I did see Little Picard theorem. Uh, I feel like the question is basically asking you to prove it though, so I didn't just want to cite it. Like I wanted to figure out like how to show that f is bounded, and then use Liouville's. But yeah, a little bit Picard theorem will just get you the answer immediately. Yeah, I think I'm gonna go back to doing puzzles because I don't know how to do it like at any of these. Sorry, Dustin. Cook up another entire function. I wouldn't know how. Oh, this is such a long one. Maybe it'll be interesting though. Hopefully, Papadoria. Okay, girls playing ball. Joggers in a circle began to toss a ball, each girl to her neighbor on the left. When the ball completed the circle, it was tossed in the opposite direction. After a while, one of the girls said, "Let's skip one girl as we toss the ball. There are trouble is half the girls will not be playing. Let's skip two girls. That would be even worse. Only four will be playing. Skip four girls. The fifth would catch it. There is no other combination. If we skip six, same as skipping four. Sure. Wait, is it? Huh. Skip 10 girls each time. We've already played that way. They begin to draw diagrams every such way to toss the ball. Soon convinced that Natasha was right. Besides skipping none, only skipping four, where it's mirror image 6. Let's all the girls participate. See A in the picture. There have been 13 girls. The ball could have tossed skipping one girl B, or 2C, or 3D, or 4E, without leaving any girls out. How about 5 and 6? Draw diagrams. Really? What's special? What? It's like 4 goes into 12. What makes 4 special? So 1, 2, or 1, 2, 3, 4. Okay, so I see. They're numbering based on like the order that the ball gets passed in. So 1 would go to 2, 2 goes to 3, 3 goes to 4. That's the low dim topologist. Two. This is like I'm looking for a way to involve like a roots of unity type of idea with this. So it kind of feels like a roots of unity thing. Yeah, I did set it to a classic rock song. This is the Stooges. Hmm. So what are the 12 roots of unity? Oh wait, I'm sorry. I haven't been showing the oh my god. What was Okay. I'll say okay, you haven't missed much. I thought I was showing my journal plus plus. That was bad of me. I wasn't drawing that much on it though anyway. Yeah, I just wanted to remember exactly how it's supposed to look. Find a branch square root of minus f. Oh, I deleted the problem. Take values only in the right half of the plane and is analytic. I don't know how that would help, Cold Gold. Okay, so we have 1, of course, and then if k equals 1, it's pi over 12. This is kind of a lot. I mean, pi over 12, and then I guess pi over 6. Isn't this... There's a 2. That's why this feels wrong. We start at pi over 6. And I guess we're going in increments of pi over 6, right? So that's going to be pi over... Pi over 3 isn't here, though, is it? Dude, why can't I... I'm really not... freaking... in it today. Okay, pi over 3 is there. Add pi over 6 again. Yeah, that's 4 pi over 6, which is 2 pi over 3. Some exp function to square root of minus f, and it's always bounded. It has imaginary exponent. I have no idea how you would show that though. Like I can understand if it's always e to, well, no, I don't know how to show the original foot function is bounded. Natasha does, Aeneas. I'm drawing out all these roots of unity because I really want to make this idea work about think about things like adding angles. Okay, so I was hoping this would be helpful. It might not be helpful, but if we're always starting at 1, in we skipping 2 or skipping 1 person is the same as continuing, like multiplying by e to the I pi over 3 continuously, right? So you do e to the I pi over 3, e to the I 5 pi over 6, 7 pi over 6, and like that. And it lands you back on 1 is the important piece. And so if you skip 2, that's like 2 pi over 3. So then we get 4 pi over 3. And then, yeah, we do come back to 1 immediately. But if we do 5 pi over 6, I think that's the first one that works. It's the same as skipping, no, it's skipping 3 people. Never mind. Wait, really? What am I doing wrong? One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I missing some roots of unity? I think I skipped some. Do I need these? Is that my problem? I don't think I do need those. Oh, wait, yeah, I do. That's 3 pi over 6. Yeah. Uh, 3 pi over 2. There we go. That makes more sense. Okay. So yeah, that'd be like multiplying by 5 pi over 6 each time. So then we get, what, 10 pi over 6, which is a number? 5 pi over 3. I don't have a 5 pi over 3. Why did I say that's 7 pi over 6, but that's 4 pi? Oh yeah, okay. I don't know. I feel like I'm... I feel like I'm just doing something weird that maybe isn't all that helpful. Why can't I bring up my journal plus plus? Seven pi over 6. I'm just checking the rest of my angles against an actual unit circle. Okay. Um, I know I've actually improved this. How many times do you need to raise a... Okay, I guess like the question is, how many times do you need to raise a root of unity to a power to get 1? That's really what we want to know. We want it to be equal to... If we have 12 roots, we want it to be equal to 12. Or like, what's the smallest number? Rather, because there are multiple answers. Power W equals z to the k of a z is a primitive eighth root of unity. Hey, Slim. I don't mind it. I enjoy a good Hawaiian pizza every now and again. How about you, Slim? Hawaiian pizza was invented in Canada? Really? Oh, good. It does have its own Wikipedia article. A Greek-born Canadian. It's a fly in here. Go away. At Satellite Restaurant in Chatham, Kent, Ontario in 1962. I kind of want a Hawaiian pizza now. Part of a series on Canadian cuisine. Bog Labrador tea sounds disgusting. It's like swamp mixed with dog in a tea. I think it just became a meme to hate on it because everyone else started hating on it. It's the same thing as like Nickelback. Like everyone loved to shit on Nickelback for the longest time. But yeah, I mean, pineapple on pizzas, it's not bad. Not even, yeah, pineapple. I've had it in a repo before. I feel like I didn't get a very good one though. It was really like overpriced too. I want to find a better place that makes them one day. You seen some little pineapple? You never trying it? Mm. Primitive eighth root of unity. Is this the actual thing that I want? Okay, wait. Maybe the way I need to think about this is multiply all these fractions through by 6. And like this is an example of an angle that works. So if I think about the numbers 5 and 6, they're co-prime, like their GCD is 1. Whereas we said pi over 3 does not work. So multiply that by 6. What is that? 2 and 6. They do have a GCD of 2. I think that's how you figure this out. That's the idea that I was like looking for. If you have pineapple on top of you, would I still like you? Yes, Slim. I would still like if you had pineapple on you. I don't know if I would eat you. A snobette? Coffee. I mean, I'll drink not fancy coffee, but I won't enjoy it. It's MDC in Portuguese? Okay. Hope you're doing well, Yonetta. Does it also explain? So they said skipping 6 also works. This is skipping 4. Skipping 6 will be this one down here. Okay, yeah. First. Congratulations on being first. Okay. So I think I wasn't crazy with thinking about roots of union either. Maybe there's a simpler way of doing it too, but we could use this to answer the question for 13 also, right? I bet there's a way to do it without ever speaking about complex numbers. But the thing that I this kind of makes the symmetry of it clear to me, at least. Like, why is skipping 4 the same as skipping 6? Just because they're reflections of each other across the real axis. Um, and so I guess we can think about. So the real question they're asking is for 13. For 13, I bet everything works because it's prime. Yeah. Uh, Playing in the same order eventually. I'm not sure what that means. Like the same order? Yeah, for 13, our roots of unity would be 1. Why am I so bad at this? 2 pi over 13. Be like this, right? Yeah. Like all the way up. And so we can multiply all these numbers through by 13, ignoring the pi's and the i's. And the GCD will always be 1, so they'll always work because 13 is prime. Oh, for skipping 4, same as skipping 6? Yeah, it's just because it's like symmetric situation, I guess. Okay, I think we solved that then. Going to 13 kind of breaks the symmetry. Okay. Let's pull the next one. Okay, 4 straight lines. Okay, when I first saw this, I thought it was going to be the puzzle. It's not this because they say straight lines, so, but I thought it was going to be the trick where like you just do that, connect them all with one line, but cross all 4 dots with straight lines without taking your pencil off the paper. Can I put more chill music? You feel like you're wasted at a pub? Sure. What's wrong with being wasted at a pub, though? Would you order pineapple pizza for your date if it is your first date? You don't know what she likes. She wants. Oh, I would not order pineapple pizza if I don't know whether they like it. Like that's kind of dangerous. Like that's pretty risky. Why would she want me to order for her though? That's a weird request. Um, I'd probably just order something that like pepperoni or like if I don't know anything about her taste, I would need I would have to go with something that's like safe, I guess. I don't know. Honestly, it hopefully I think pepperoni's the safest, but hopefully we've gone to a place that has the actual good pepperonis that like curl up and burn a little bit, because that's the best pepperoni pizza. This one is a famous one? Okay. This book is called Moscow Puzzles. It's translated as originally in Russian. Boris something. Kordemsky. Edited with an introduction by Martin Gardner. Translated by someone else, Albert Perry. Ooh, Perry with like an A. It's a cool last name. Everyone with basil? Oh, like a margarita pizza? That's what I would order if I went to like a nice like actual Italian pizza place. But for like American pizza, I mean, my favorite pizza is uh bacon garlic jalapeno. The Devil's Signature? No, I have not heard of that. My elementary math teacher started taking me seriously when I solved this problem after he gave it to shut up the class. Oh, nice, Yonetta. You have a candidate for the safest one? Margarita pizza? That is a safe one, yeah, because it is good. Um, yeah, I just think of like your average American pizza place doesn't care that much about making a good margarita pizza. I don't usually order them because of that reason. All beer, no sleeps makes my typing skills a dull boy. Sounds like you had a good night though. They they may not eat pork. Okay, I mean they if they have a restriction like that and they just say to order for them though, they better say it. They're probably gonna get cheese if that's the case, because like I don't know what they typically make. Like yeah, the sausage usually has pork in it too that they use on pizzas. All countries I've been, what's the best cuisine in my opinion? Oh, I mean, I've only ever been to Japan. But if I'm just naming like from the restaurants that I've tried around me, like what country has the best cuisine, I my mind immediately goes to Mexican food. Yeah, I think I'll go with Mexican food. Italian food is a is a contender though. Japanese too. What if they are lactose intolerant? Oh yeah, I mean lactose intolerant. You just shouldn't be at a pizza place. I mean, some places will do pizza without the cheese, and it's actually not that bad. Not as a date, but I've been out for pizza with lactose intolerant pizza, and we have ordered pizza without cheese. Lebanese cuisine is great. I do really love um like Middle Eastern places in general, like falafel and hummus and all that stuff. That's what comes to mind for at least the Middle Eastern places that are around here. Yeah, Italian and Japanese are always like when it comes to discussion about like which country has the best food. Those are like the two kind of like common choices, I guess. Hey Chandu, you like Japanese food? You're not a huge sushi fan. Me neither. Uh, Ramen is great though. Ethiopia. I'd never had Ethiopian food. I'd like to try it one day. Um, so wait, I assume like we have to do straight line, like or so at the straight lines it's gonna be like this, isn't it? Well, we don't have to do it like that. We could do it like that, that, three. Damn it. One, two, three. Damn it. One. There's no way diagonal will be the right first move. Gotta think outside the box. I I assume I can't curve out here though. That I don't think that would count. And I don't think doing this is any different. I don't know. Uh limit n goes to infinity. Mom Toddy Wari square root n squared minus n minus 1 plus n alpha plus beta equals 0. 8 a plus b is equal to uh we can probably do that one. I'll think about it more in a second. Mom Toddy Wari. Chandu asks, can you share some math study tips with me and problem solving tips? Uh, Chandu, it's really hard to answer that aside from just practicing. The problem solving is all about pattern recognition, and you're not going to see the patterns unless you just do it a million times for yourself. So it like there's no really trick. It's just hard work. Some girls don't like to go eat on the first date. I mean, that's true, Dustin. Like coffee or a drink or whatever is a really common first date. You know, trick this one, but it's a classic. Instead of going 90 degrees, second trace actually took also some points. Oh wait, or no, wait. How do like something like that? That's almost I could almost cover with 4 lines, but I'm gonna miss out on one of these dots. Uh, your practice where you get stuck. That you just have to work through getting stuck, Chandu. Like there's nothing I can really say to you that's gonna get you unstuck. It's just hard work and perseverance. I'm sorry. Yeah, and people in chat are maybe giving some better advice than I am with starting with simpler cases. Then go left. Really? Uh, I don't see how we can do it from here though. Outside the box. I mean, going further over here. Oh, haha. Okay, there we go. Nice. You didn't ever worked it out yourself? Just saw the solution as a teenager? Yeah, I'm more familiar with the one where like they say just one line without saying straight, and they just do like the curvy thing. But this one's definitely it's a harder version. Make a square. I mean, I guess it's a filled in square Papadoria. I don't know. Try to delay giving up. Get the answer in the back of the book. We're asking ChatGPT as much as possible. Yeah, there's definitely like a practical issue with like, um, you got it wrong. Okay, with like you only have so much time, so sometimes you have to look at the answer. Devil's signature, and then we'll do Mam Tadiwari's problem. It's a movie. What about it? I never heard of it. Was it luck? I don't know. I think it was skill on your part. Signature made by the devil. I Yeah, if you want to tell me which one of these links to click on, I'll click on it. I don't know what you want. There's a lot of things that are coming up. Um, yeah, Papadori, that does look like a JE problem. Um, I think it's a doable one though, unless I've gotten arrogant. This is a common enough type of limit to evaluate. No, I normally say no to solving JE problems because I don't know how to do them. I think this one I might see the idea though. True Fembox, yeah. Artsy fartsy films. Uh, I haven't watched too many of them. I don't. I'm not a very artsy fartsy person in general. Um, it can be good though. So yeah, whenever there's a square root involved in a limit, this is usually a good thing to do. If you don't have an immediate thing that you can figure out to do first. Cool. We need our limit out front still, it's important. N alpha plus beta minus root n squared minus n minus 1. Now what? Your fighty sense is tingling? Is there a golden ratio in here? Couple of movies before. This one works very well as a thriller. Probably enjoy it for almost anyone. Interesting. You know what the devil did, but won't tell. This is the devil's signature? Okay, and you're thinking of it because it looks like the solution to the problem? This is fantastic art, Dessen. How do we do it? Ooh. Okay, I guess make my YouTube profile picture true Papadoria. I guess we can factor. I mean, okay. First things first, let's multiply out the numerator. Over the same thing. I don't want to repeat it. For the sake of speed. And then alpha squared minus 1 n squared plus 2 alpha beta plus 1 n plus beta squared plus 1 n alpha plus beta minus root n squared minus n minus 1. And then I'm going to factor in n squared. No. What am I going to do? I didn't realize the degree on top will be higher after doing this. Oh, wait. Okay, in order... So, what we have is a degree 2 polynomial in the numerator in n divided by a degree 1. And n is going to infinity. So we need to require that this number is actually 0, so it's not degree 2. And also this number is 0. So we get degree 1 on the bottom and degree 0 on top. That's the only way for this thing to result in 0. And that's what Fenbox has just gotten there. So we're going to set alpha squared minus 1 equals 0 into alpha beta plus 1 equals 0. Alpha is plus or minus 1. Two plus or minus 1 beta plus 1 equals 1. Plus or minus 2 beta equals minus 1. I think it's probably confusing if I'm just going to say alpha equals 1 for now. 2 beta plus 1 equals 0, so beta is minus a half. Alpha equals, I mean, this is kind of a crappy problem if there's two answers. Actually, the sum might come out to be the same if it's just a sign flip, though. 2 beta plus 1 equals 0. Okay, yeah, it is just a sign flip, so the problem is fine. So 8 times 8 alpha plus beta. Alpha plus beta is... Well, it's either minus 1/2 or plus 1/2, which is annoying. So the answer is either 4 or minus 4, depending on your flavor. Or depending on, I guess, your preference. Storm, it's been a minute. How are you? We're just working on this problem from a person in the YouTube chat. I think we solved it. You bet one is right and the other is wrong? Oh, maybe. Maybe we should check it with the original. I missed out on a few chats. Let me scroll up and see it. Frickin' Twitch chat. It keeps scrolling me to the bottom. Okay. Solution to actually famous 6 IMO problem that Tau couldn't solve? Really? At least an idea the solution had the same idea. Interesting. An Eulerian path, hence impossible. Thought it was possible. Has anyone seen Collar? I have not seen Collar. He said hi maybe like 2 weeks ago in my chat. He has not been hanging out as much as he used to, though, so I hope he's doing well. I'm not sure, though. Should you post asking for information on Collar? Yeah, and put his picture on milk cartons. Bought a book about Euler since I was in a math history vibe. Haven't started yet, but it seems fun. Oh, yeah, that should be a fun read. Collar disappears during summer, probably enjoying time with GF in Quebec. That's fair enough. Having a life. Or the Master of Us All is the title. Oh, cool. What's my favorite math tale? I gotta think about it. I'm not sure. It's quite a long time ago that I saw you on live. Started studying relativity. Oh, yeah, Storm. That was a while ago. I think that was like a year ago now. We got... we stopped... We got stuck and we stopped, basically. I'll bring up the textbook that we were using. What? Frickin' Google. I guess I'll show the table of contents. So yeah, Felix and I were working through it. We got all the way up to... I think chapter 8 on geodesics. That's the last chapter that we read. And after that, it just got too complicated. That's about where we stopped. We didn't... I feel like we still didn't even get into real general relativity. We never learned anything about like tensors or anything like that. So it's something that would be cool to revisit someday. Who streams math in the chat? The only person who's here right now is Slim, Academy of Useless Ideas, Fook Life. But I do have this like list of people who stream math in general, too. Hope we know well, Fook Life. Reflect to those milk carton pictures so they find many people that way? I don't know. I feel like it wouldn't be that effective. We could have completed the square under the radical here. Oh, yeah. You like the one about a student asking von Neumann if there's another way to prove a certain theorem, then von Neumann paused for a minute or so looking at the board, exclaiming, yes, there is, continued lecture without showing what it was. That is funny. Storm. So I just finished a master's in applied math. I guess a month ago now. I'm still very burnt out and kind of struggling to do math in general right now, so I'm not doing that much. I am applying for jobs and working like data analysis type of stuff. I need to stop putting off Femvox. And we're going to do a reading group on a book called DivGrad Curl, so just multivariable calculus stuff. That's still like to come though. I don't want to read an algebra book for tensors. No worries, Fook Life. Most differential geometry books don't explain differential forms very well. Fair enough. For a equals 1, we get infinity plus infinity and infinity minus infinity. Really? Yeah, I'm all done, Desson. Uh, yeah, like in Discord and on stream. I mean, right now, I was unemployed doing math for fun, and I am back to being unemployed doing math for fun. Uh, so yeah, for about a year or so, I was a student, but yeah, uh, unemployed doing math for fun is accurate. But yeah, I don't think I've even shown it on stream, but I do have this. But plot twist, I don't actually have my diploma yet. All I have is the thing that holds it. Yeah, Chandu, I have in the past done reading groups, where we basically meet each week, and people can jump in Discord and we solve problems together. I need to get one starting. I need to start one up again. I just am struggling to like do math right now because I'm just tired. Also, something it's fake. Yeah, Papadoria. Being unemployed and doing math for fun isn't. It is. Yeah. Um, the real the diploma should get mailed pretty soon though. I think. Also, something similar about Dirac. Someone raised their hand and said, "I don't understand equation X." Dirac continued the lecture without explaining equation X. To repeat the question was once again ignored. Someone pointed out that Dirac previously wanted an explanation. To which Dirac said something like, "I thought you're merely making an assertion." uh, math people are really funny like that. You know, if there's any open spots, so I can also sell my soul. Those on Slums cards. Okay. Being unemployed doing math for fun is my. I mean, being retired doing math for fun would be cool. If you're unemployed and don't have enough money to like, live the rest of your life, it's not as fun. But yeah. Storm, I do want a PhD. I'm kind of putting that aside for the time being though, because I've tried a few times now and it hasn't worked out. And so I'm going to try to get a job and save some money, and maybe in the future I'll try again, but applying for a PhD is a long, tedious, and expensive process, and actually getting a PhD, even if I do get accepted, is a even longer, more difficult process. So be poor and just doing math and die like Archimedes, except the killing part, just the doing math part. You don't want to die drawing math in the sand while there's a battle happening. I would want to do a PhD in something that's applied math. No hate towards like math ed degrees, but if I'm going to do a PhD, I want to do it in applied math. Oh, like actually getting into a specific niche. Like, yeah, it would be cool to do like computational biology or something too. Trying a PhD, it took quite some time. Yeah. So how do we think about like so if I said one of these limits gives you infinity plus infinity versus infinity minus infinity, how do we figure out which one is right or wrong? So we know these numbers are 0 no matter what. So the only thing to care about is the bottom. Uh, yeah, don't we? I mean, don't we want alpha? Don't we want alpha to be -1? Because we want negative infinity minus infinity, right? In order for this limit to be 0. Speaking of math history, there's An argument's made that Archimedes didn't die merely because he was too focused on geometry and ignored the soldier. It's pretty patriotic. Yeah, like Archimedes like inventing stuff to help defend his city, as far as I know. Okay, so I guess it's not a crappy problem. We do want alpha to be -1. I think you have minimal chances. Again, I'm lucky to have met no professors, so fingers crossed. Oh yeah. Good luck, good luck. I can recommend a podcast here in the chat. Opinionated Math History on Archimedes' Death. Opinionated Math History is a funny name for a podcast. At least they're honest about it. If they're going to be opinionated about history. Ask someone's acting me my letter of recommendation writers. Ugh. I would hope that I could ask professors that like I just took classes from here at UW, but I think if I remember right, Dr. Cook might have actually offered me a letter of. Oh yeah, he did for because there was one place I applied to a master's for physics, and he actually did offer me a letter, but I had already applied and it was like too late. I mean, is the opposite of Los Alamos project scientist, I guess. Do not disturb my circles. Okay, I don't know what that means, Arcane. Piano history, mathematics. Oh, close enough though. Okay, I guess we'll go back to doing puzzles unless there's a question someone wants to ask. So we just did 24. Oh, those were his last words. I didn't know that actually. Oh. Let's see what's up with this puzzle. Now instead of joining points, separate all the goats from the cabbage in the picture, drawing 3 straight lines. Separate all the goats from the cabbage in the picture by drawing 3 straight lines. Well, this one kind of screams out to me. Doesn't this goat need a fence like this though? Like, how is that going to work? 3 fences? Yeah. Favorite last words of all time by famous people? I don't know that many people's last words. Do not try to gain other people's favor. Do not wish for wealth. John Doe, it's called The Moscow Puzzles by Boris something something. Yeah, I can't name anyone's last words, to be honest. Besides, I don't feel so good, Mr. Stark. Ulam worked on the Manhattan Project. There's an Ulam biopic out there. Oh, okay. Do not try to gain other people's favor and do not wish for wealth. Do not try to gain other people's favor? Why not? Oh, true. At 2, Brutus also. I do have a line tool, yeah. Oh, Saints would be a good source for last words. It's kind of weird, this, like, something like this, we would need to... Only 3 lines seems so difficult. I assume we're allowed to pick up our pencil, though. I hope we're allowed to pick up our pencil. St. Lawrence, while being burned, turn me over. I'm done on this side? Oh my god, that is metal as fuck. Oh. Well, that was easy. I assume we're allowed to pick up our pencil for this problem. I don't know if it's possible otherwise. I know the poor goat in the middle has like no room to do anything. Um, I don't. Maybe this is the wrong St. Lawrence. There might be multiple St. Lawrences. I'm not seeing Burned Alive though. Oh, that is it? He was on a grill in some of those pictures? Oh, you're right. I didn't realize that was a grill. Your page doesn't seem to have that quote though. Yeah, oh well. According to all your historical movie experience, what lifetime would I like to live? Uh, I think the easy answer is like the Star Trek universe. I never really watched Star Trek, but that's like a utopia with really cool technology. Unless you mean in the past. Yeah, I think the present is always better than the past. Like, you would not want to go very far back in time if you do go back in time. The Death of Sardanapalus or something? Painting. We were seeing it for the first time when I was about 7, fell in love with historical movies. No. Death of Sardanapalus. There's too much going on in this painting. I don't know who's doing the dyeing here. I don't know. I always feel stupid when I look at art like this. Like, I think there's too many things like you need to know about the historical context to know what's really happening. Um, is this an easy one? Let's see. 40 miles per hour and 60. How far apart are the trains 1 hour before they pass each other? Oh, is it 20 miles? Wait, no, 100 miles. You add, not subtract. Yeah, 100. Oh, that's a line tool. Also, hey Rex, how can you tell when a Burroughs salesman is lying? I don't know. What is a Burroughs salesman? Oh, we got a joke puzzle. Let's see. The tide comes in, a joke. Not far offshore, a ship stands with a rope ladder hanging over her side. The rope has 10 rungs. The distance between each rung is 12 inches. The lowest rung touches the water. The ocean is calm. Because of the incoming tide, the surface of the water rises 4 inches per hour. Assuming water cover the third rung from the top rung of the rope ladder. Wait, what? 10 rungs, distance is 12 inches each. Isn't this just like a rate, like, so it's 120 feet in total. You got this wrong the first time you tried it. Okay. Well, we need to cover 7 rungs, presumably. Wait, the third rung from the top. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll pass, Destin. I don't want to do that. Third from the top. 1, 2 is this one right here. So 1, 2, 3, 4, 5, 6, 7. So 7 times 12 is 84. So we need to cover 84 inches. I mean, isn't the ship going to rise with the tide? So the answer is never. Yeah. Okay, that's just a bait. Never. The rising tide raises all ships. Okay. Can you divide the watch face with 2 straight lines so the sums of the numbers in each part are equal? Divide the watch face with 2 straight lines. The sums of the numbers in each part are equal. Wait, oh, 2 straight lines. Huh. This is like the reverse of the triangle problem. Really? That's kind of challenging because the numbers are sorted. I guess let's start by drawing one straight line and seeing if we can find a... Ooh. They don't have to go through the center, do they? You could do something like that. I don't know if this is good. What is that, though? Why can't I do 11 plus 12? 23. 26. 19 plus 7, 26. 15, 21, 20. Wow, okay, look at me go. What even is a Collette's orbit? Is that just when you do the Collette's conjecture? Like, what's the sequence of numbers? Um, so you take 23 and multiply it by 3 and add 1 until you get an even number. That could take a few iterations. It's I assume you put a kappa there, so I assume it's going to take a while to get to an even number. Let's see. Hey, 69? No, you get it immediately. So then you just keep dividing by 2. Oh, never mind. I forget. Yeah, um oh, thank you, $5. 105, 106. 53. Destin be messin'? Yeah, if it doesn't settle down into the Colette's thing soon, I'm just gonna not do it, but 159, 160 becomes 80. Hey, okay. No, we're still gonna get an odd number at some point, right? It's not a power of 2. Yeah, we'll get 5. Wait, sorry, I skipped over 10. What actually is the thing you always settle into for Colettes? Four, two, one? Or that you supposedly always settle into that we can't prove? 124, 124? Okay, okay. It's pretty much done. Yeah, because then we get 16, and that is a power of 2. There we go, and then that loops back around to 4. Okay. See, I actually did it. Yeah, the Colette's conjecture is one of the weirdest things. Like, just seems like a thing that shouldn't be that difficult to prove, but it is. You divide it into 6 parts, so each part contains 2 numbers, and the 6 sums of 2 numbers are equal. $10 Dessen be chilsen. Actually, wait. Yeah, I assume Dessen picked a mean one. That one could have been a lot worse. Six parts. Icosahedron? How does that look? Polyhedron with 20 faces. Convex and not convex. I mean, I could just replicate this drawing on the left here. Oh, are they related to number theory somehow? $10. Draw all of the edges. Even the ones we wouldn't be able to see. Oh gosh. Let's see. If I can do it. Dotted lines? Okay. Construct an icosahedron using a golden ratio. Oh. So wait, I need to work out how this looks. It has 20 faces. 1, 2, 3, 4. And there'll be another 4 in the back is 8. And then on top, 1, 2, 3. Is that 6 and 6? 8 plus 4 plus 6. Okay, that is 20. Probably easier versions to draw out there? Really? I think I can do this. Let's see. Oh, I'm still on the line tool. The surface that has 27 straight lines. I don't know what that surface is. Gombach? God. This drawing is already getting off the rails. I'm just drawing the front part for now. We'll fill in the back part right after this. This is where the perspective gets difficult. No, I can't do this. I don't, well, can I? One, two, three. There's 4 vertices showing. So wait. We need 3 more faces on the backside. That's 1 face. So we need 1 more vertex over here. Which means we need another vertex down here. Maybe I can actually do this. So we just connect those like that. Connect those like that. And then these need to come down here. I think I did it. I kind of, like, this part feels kind of janky. I want to say I got all the edges correctly, though. I want to study some algebraic geometry. Recently trying to get in touch with anything geometrical. Oh, nice. What is the Gombach? Any member of a class of the convex three-dimensional homogeneous bodies that are monostatic? One stable, one unstable point of equilibrium when resting on a flat surface. It sounds like there's not the Gombok, there's many Gomboks. It moves on its own, kinda? Gombok walking? Huh. Interesting. Not algebraic geometry courses for now. The best algebraic geometer in my department actually works on some weird complex geometry and mathematical physics stuff. Interesting. Yeah, if Color Cone was around, he's like Mr. Algebraic Geometry. But we're just talking about how we haven't like seen him in a while. Oh, it has a mind of its own. Look at that. Colors the Canadian Grothendieck. But I want to see what's on this gombok-shop.com. I feel like it's gonna be like the Klein bottle guy. Perfectly relaxing, perfectly inspirational, the perfect body with the perfect shape. I thought that was my body. Black Gombok light. Oh my god, this is everything Gombok. But he just keeps on rolling, barely slows down until like 4 minutes later, hence walking. Interesting. Well, you can spend a lot of money on Gomboks. Dude, a Gombok feels like something that like you would see in a Rick and Morty commercial. Can we see this in action? Quinner polished finish. Why did that get auto-modded? You would pay any price for a full tungsten Gombok? That would be very expensive. The like geometry is somewhat concrete, not as concrete as concrete, yeah. First interest in math was set theory. Doing dynamical systems, really, that seems kind of out of the blue, but dynamical systems are great. Except the set theory part. Oh, I thought it was a light as in something that produces light. But light refers to the weight. Wah, wah. A diamond gumlock? Yeah, I think it'd be really cool if these could light up. Polished aluminium. I mean, this would be if it wasn't like, you know, several $100s, this would be a fun thing to have on like your coffee table or something. Or on your desk, just like play with. You didn't actually like ODs before learning some dynamical system stuff? Dynamical systems are fun. Symbolic dynamics. I don't know what that is. Constantly asked question has a much cleaner solution. Oh, okay. Uh, I'll bring it back up. I'm not gonna do it. I'm not gonna try to do it for myself, but we can at least try and understand what you're saying. Cold gold. I guess I'm gonna call that good for the icosahedron, Yonetta, unless I missed something. So this is the one that Cold Gold was talking about. I think there's a missing edge, so refund. Is there a missing edge? It's possible. I'm not gonna find it. I could refund it. I don't really care. Cold Gold is saying, in the bottom left? That's what I was wondering, if it is in the bottom left. I still don't see it, though, to be honest. If f of c misses all positive real numbers, principal branch of log to define the function exp I ln minus f of z, where f of z is equal to r e to the I theta, where 0 is less than or equal to theta is less than 2 pi. I assume that's a principal branch, right? Not like minus pi to pi. It is minus pi to pi? Oh. Maybe. A Gombach roller coaster? I don't know if I'll call that a roller coaster. This has modulus at most exp pi. I don't know why I said exp like that. Oh, and so the the maximum of this thing, or the maximum modulus, happens when the argument is minus pi? Because it becomes e to the I ln r plus I theta. And so you don't need to care about r, you only care about theta for the modulus. And so minus pi gives you the maximum I don't understand. Wow, how does that show you f is bounded, though? I don't think it says anything at all about our original function f. Whoa! Anonymous gifter, holy crap. Thank you so much for the 10. Whoever you are, I really appreciate that. You got some good people in there. Dude, I forgot I had that alert too, but yeah. Thank you again so much. Thank you, Colin. And I just like automatically put it on the hype train level 3. Never win any gift. I mean, if you're already subbed, you can't get a gifted sub. Oh, okay, your cap. That's just the way Twitch does it. I guess they could extend your sub if you got a gifted sub, but I guess they choose to only ever give it to people who aren't currently subbed. The point of having a branch cut. I don't understand. What does this do? Oh wait. Uh This is a bounded analytic function, but we have to show it's bounded. So I know once we know it's bounded, then Liouville's tells us that it's constant. Is this, but like what, do I need to think about like the log identity? Is this, if once you define your branch, can you say that this is equal to minus f of z to the power of I? And so we have bounded that by e to the minus theta? Or e to the minus pi? You gotta get the sub here once or twice so your luck has ran out. Yeah, I mean, that's the first time I've gotten gifted subs in a long time. Actually, well, no, that's not true. That's the first time I've had like a 10 bomb in a long time. So it just doesn't happen too frequently. On the bright side, though, I only run pre-rolls on this channel, so once you just see like the 30-second ad ones, there shouldn't be any other ads for the rest of the stream. Function defined as bounded, hence constant. No, you don't need to show f as bounded? I really don't know how this works then. It has imaginary exponent, so it's sine and cosine less than 1. Well, this isn't purely imaginary. It has a real part. So I don't understand why showing this, the modulus of this is bounded, tells you anything helpful. Yeah, sure. It's analytic. Oh, is this another is this an example? We're defining an... Okay. Does this... Are you saying this function also meets this criteria? Does this ever map to a positive real number? It can't, because of ln of r. ln is not 0. Huh. Okay. I didn't think about that cold gold. Oh, I got an emote for that hype train. What did I get? That's not a bad emote. Okay, so I'd never, that thought never even crossed my mind. So we're saying this is our new f of c in this theorem. Okay. Frog train, yeah. Apply Liouville to a bounded analytic function, so you produced one. I guess so. Linear inequalities in one variable is fun. Oh, are you doing like the thing where like they have you shade in the number line famished? If you have like maybe between like 3 and 5, you might have like an open dot and a closed dot or something. For the other exercise, you can find h as f of x plus, or f of xy plus igxy and apply chain rule. Oh, okay. Fun unrelated fact, let fcn to cn be a polynomial map. F of z is equal to f1z fnz, where fi is a polynomial for all 0 less than I less than n plus 1. Oh, so it's the degree... Oh, never mind. If f is injective, then f is bijective. I have no clue why that would be true, but I can believe it. F is not the function, F is the tool. Yeah, it is. Injective implies bijection in finite dimensions. I don't know why, but I can go with it. That's next. It's a measure a range for a variable. Has to determine the age range for which the average height of a boy is no more than 46 inches. Oh, okay. Fair enough. Oh, I didn't post this in the Discord, did I? My amazing art. I don't know what the I've looked at this too much. I don't know which one is, I don't know what edge is missing. I really don't see it. Oh, is it connecting here to... Oh, maybe I see it now. It's this edge? Which I guess we should be able to see that edge. Right? No. I haven't drawn it very well. It should be dotted. I just didn't do a good job of drawing this. If I was copying this perspective, at least it should be dotted. Okay, you know, I can make it solid if it makes you all happy. It's easier to draw anyway. Yeah, it's undergone a transformation. Probably not a linear one. Oh, I already refunded that. Sorry. I thought that was just a joke. Ecosagron is happy to see us. I guess so. And fair enough, Pistol. So I'm not going to spend the time to fix it, but yes, it's definitely not a perfect icosahedron. Famish posted this just... So wait, so Famish, do you want to actually get the answers for this, or are you just like sharing what you're working on here? Service with 20... I mean, I can Google that. I don't think it's going to find whatever you're looking for on Google. Oh, never mind. A cubic surface? It looks like it's screaming. I can't be the one who sees a screaming mouth in this, right? In the middle. You already solved it? Okay. I'm the only one? Damn. That's the way my brain works, I guess. Yeah. Oh my god. This reminds me of the thing we were doing with counting triangles. That's what she didn't say. It's a Schleife graph, whatever that is. I don't know. It means something in some part of math. Linear algebraic group? Sure. That's what she didn't say, not Michael Scott. Mm-hmm. E6 Denkin diagram. Okay. Okay, let's look at the first one just to get a sense of what you're working on, then famished. Average height for boys based on age. A represent the boy's age in years. H represent his height in inches. Why would you scale a graph like this? You have all this wasted space down here. Actually, you know, that's actually, I take that back. This isn't a bad scaling for a graph. It just weirds me out. But I guess you probably don't have data for earlier than that. Never mind. Determine the age range for which the average height of boys is at least 51 inches. Find Famish really funny. It's like he doesn't even try. Famish is always working on stuff. And there's multiple right answers for this question, but I would put a dot at age 51, and I assume they want the the age range with the maximum width. And so it's about 8 years old, and so I would say somewhere like, if we can go as far to the right as 10, then we can go to the left with the same distance too, so 6 to 10. That's probably what I'd say for 43. If you look Dinkin up, he looks like such a happy old man doing maths in his bucolic countryside house. Bucolic? That's a fancy word. I think I've heard it before. I don't know what it means. Pleasant, idyllic, rustic aspects of the countryside. Ooh, okay. Dinkin. I guess he's chilling. No, do you think that's real? That's your impression of him. I don't know. Died in Ithaca, New York, at age of 90. I mean, upstate New York. I can see that being bucolic. And how you reacted on the graph from the wiki. Oh, okay. Yeah, I mean, Famish, I'm right there with you. Whatever's happening in that graph is something that I don't even know the first thing about. That's what you want to be, yeah. Yeah, folks, I was just thinking that he's probably in your neighborhood. That's a funny time to he died at the age of 90. He was an atheist. That's a strange time to mention his like religious beliefs. I feel like someone's gonna edit in, so he went to hell or something. Yeah, he died godless, exactly, Leo. Bucolic is less fancy in Romance languages, somewhat fancy, but not too fancy. Oh yeah, no, that's like a... You do not hear people use that word in like normal English. Well, it's just like they're just like speaking casually. Easy to understand. Gatekeepers like to talk fancy stuff. It's like Cartesian x and y axis. Imagine many more lines of different sizes. Highly symmetric figure, so it's a group. Sure. I don't think I still don't get it personally, but oh, it looks like a drum. What? I already forgot what page it was on, Leo. We were talking about a Dinkin diagram. Or no, it was a Schleife. What was it called? Cubic surface? Was that it? Okay. My contribution to what a cubic surface is that this looks like a screaming mouth in the middle. That's all I'd say about this. But we were talking about this Schleife graph thing here. I don't know anything about it. Dustin is trying to explain it, but I don't think it's gonna help. Uh, one English word I recently learned is Zen, Zeizen, Zeizen, Zig? Something to the 8th power. The hell? Yeah, I know I couldn't name Ivy League schools. Huh. That's kind of fun. This was before we had our modernization for math, I guess. So you want to do a Math Monday on apparently Leo. No, or maybe one day. Okay. I mean, maybe you could make it interesting. That's that I don't really care about Dinkin diagrams right now, though. Now you disappear. Okay. Well, thank you for appearing, even if momentarily. Um, I never did the second part of this puzzle here for the watch face. Can you divide it into six parts that each part contains two numbers and the six sums of the two numbers are equal? Can I do that? I immediately want to group the 12 and the 1 together. That'll give us 13. But then that everything else is messed up though. Oh, actually, yeah, 6 equal. I can't even draw another line after this. Cornell's an Ivy League school. Oh, yeah. I mean, is the Ivy League even an official thing, or is it just like? Uh, oh, it's an athletic conference. Okay. Dartmouth, Cornell, Harvard, Brown, Yale, Columbia, Princeton, Penn. Fair enough. As official as the Justice League. Yeah, I mean, I guess it's official in the sense that there is something actually called the Ivy League, but it's not for their like. It just happens. They just happen to also be prestigious for their like academics and like very old by American standards universities. Imagine learning how to handle a katana while solving these problems. While you were out talking to girls, I was studying the blade. Okay, so again for this, we don't have to go through the center though. Can we be sneakier? Can we get something like that? One, two, three, 4, 5, 6. That's all 13. Yeah, okay. The famous puzzle states that a hunter leaves his camp, walks 1 mile due south. He then walks 1 mile due east. Finally, he walks 1 mile due north. Finds himself exactly back at a starting point. Then he sees a bear and shoots it. What color is the bear? Martin Gardner poses the following. The North Pole is not the only starting point. Oh, satisfying the walking conditions. So it's a polar bear. Can you find another spot on Earth from which a person could walk 1 mile south, 1 mile east, 1 mile north, and back? The South Pole? It's like a spherical geometry question. But wait, if it's a... Yeah. I'm about to say, if it's a sphere, there's nothing special about the North Pole. You can do that anywhere. Not the South Pole. But, like... I'm trying to think, because, like, if... Like, if I in real life walk a mile south, then east, then north, I don't end up back where I started. But if it's a sphere, no point on the sphere is special, right? Like... I'm confused. I don't know what's real. Ron Gardner is the absolute goat whose books I grew up on, so you already know a lot of these problems. Ludwig, is there a way to know whether to model a function to a quadratic formula versus the exponential one, given a few x, f of x points? Get confused between ax squared plus bx plus c, f of x equals ab plus, or ab to the x. Well, if you have real data, Ludwig, no. You have to, you kind of test them both and see which one seems to work better. Or you would have some context from the problem that would indicate which one you should choose. If the lines, or if the data isn't real, meaning it perfectly lines up with one of those two types of functions, as long as you have 3 points, that's enough to determine whether, well, maybe even is 2 points enough? No, it's not enough. Is it enough? No, it's not. I think you need 3 points. So, Ludwig, what I'm saying is, if you have data that's just like kind of in a cloud, but showing a general trend, you don't know just from the data whether that's a quadratic or exponential behavior. But if your data happened to perfectly line up and looked more like this, you could try to fit these points to a quadratic or an exponential, and only one of them would work perfectly. So I'm not sure like which context you're working in, but why did my cursor freeze? What the hell? Okay, I think that fixed it. Did it? No, it didn't. Weird. When I move it with my tablet, my cursor doesn't move. that been happening the whole stream? That's gonna bother me. What? When I move my cursor with my mouse, you can see it on stream. When I move my cursor with my tablet, it stays still. I don't know why that happens. Okay, let me catch up with chat. Given a second degree arithmetic series, you can derive a quadratic function, right? South, north, etc. are defined in a particular way on our sphere. I'm confused now. There are some points on the sphere besides the North Pole that satisfy that condition. There's a North Pole and a South Pole. Okay. I think Ludwig is onto something here. He's closest from parameterized spaces of quadratic functions, hence a modular. I mean, maybe, Desson. I don't know about that, though. The illusion of algebraic geometry seems cool that polynomials are the best thing ever invented by humans. Ooh. There's some other points in the sphere besides the North Pole that satisfy that condition? So I need to draw this out, I guess. If this is the North Pole here, I guess you can walk in any direction and that counts as south, right? And then you travel a mile east. Okay, sure. Well, the only other special point is the equator, right? So let's see what happens with the equator. Let's say I'm right here. I walk a mile south. I don't know. I mean, I might not be drawing it right. I think it has to be the equator, though. Like, there's nothing else. Like, it can't be the South Pole, because you can't walk south from the South Pole. So what else could it be if not the equator? When you walk north/south, you're on a great circle. Sure. When you walk east-west, you're not. Okay. No, I still don't know. I can't, east-west paths are in circles of constant latitude. So does the bottom part need to be on the equator? I don't know. I just drew it like that, like it's a triangle. I don't actually know if a path like that would be a triangle though. Versus something like that. Yeah, I don't know. I find that confusing. What did Destin link earlier? Grothendieck paper? Oh, this isn't even math. It's just like, I don't know what this is talking about. Okay, I don't know. Yeah, Fenlux, I need a hint. This is confusing me. This spherical geometry. Oh, I'm getting really tired too. Spot near the South Pole. 1 mile's a full rotation around. Oh, Ludwig. That's really smart, Ludwig. Well done. So yeah, if you start 1 mile north of the South Pole, then walking 1 mile east, I guess you're just spinning in a circle or something. And you just come right back up to where you started. That's really clever. I want all of you rooting for Spain to tomorrow. England's trashing France. Wait, because Spain is playing Argentina, right? So is there? I guess that would make sense if there's like a Brazil-Argentina rivalry. Dustin is also rooting for Spain. Interesting. The non-Argentinians want Argentina to lose. Nicely done, Ludwig. 1 mile north of the spot with 1 easterly mile. Yeah, I guess so, Ludwig. Argentina's the worst. It's just banter. Yeah. I figure. Okay, Papadoria posted a problem. It looks complicated. Let's at least read it, though. Problem my brother and some students from the class I'm teaching typesetting gave to me. If anyone would like to try, here you go. Like messy quite a bit. Something can't begin to mention reading for Argentina. Fair enough. It's a bit much of a problem. Okay. I just want to see what it's saying at least. I probably won't try it, but if M of U denotes the space of meromorphic functions, find an open domain U subset of C. For any H in MU, let P of H denote its discrete set of isolated poles. Find the global exponential residue operator R acting on H by summing its local residues against an exponential kernel. Oh my god. Where W is a complex parameter treated as the constant with respect to the residue evaluation. Okay. Construct an iterative sequence of functions governed by this operator as follows. So we're repeatedly taking residues with a kernel. Characterize class meromorphic starting functions f of z such that the infinite limiting function converges to well-defined. Oh my god. Yeah, I can't do that. Jeez. Here's the example of to make sure the reader says what the problem statement is. This f of z example does not work though. Just residue of residue of residue. Yeah, I've never seen something like this either. 1 over z squared minus 1. We only have two poles. They are both simple. G1, W1 has an elegant form. Cinch. Cinch is an entire function. Okay. Well, that makes me feel better about this problem. I still don't know how the hell you would do it, but that example is helpful. This FZA's enable does not work though? Why does it not work? Hey, Skirt. A vivid and creative mind characterizes you. That's a lie. Your mind is all violence and blood. You'd be a mile north of a smaller circle that has a half-mile circumference, or an even smaller circle. A mile north of a circle. Smaller circle that has a half-mile circumference. Oh god. Okay, Fembox. You can get creative with violence? True. And vivid. Brazilian followed Cape Verde's GK a lot on Instagram. He's a bunch of followers now. Oh, funny. This problem asks for nu of lambda to be not 0. Okay. Oh, I see, I see. Whole point of the problem, find a starting function's iterated residue is not 0. Really? And so if it's meromorphic, you can't, like, that's not essential singularities, right? They have to be poles. Yeah, so even finding one that gives you non-zero residue infinitely would be a challenge, right? They have to be poles? Okay. As your journey 1 mile east can spin around the Earth any number of times. Yeah, I guess the circles are like converging on the South Pole, but there is some like how do you call it? It's not just a single point where it works. It's like a continuous region that you can make work. If you think about it, the only way for this iterative residue to convert something non-zero is if your starting functions, and also this would use have infinite poles. Yeah, but wouldn't that be an essential singularity though? Like that's no longer a meromorphic function is the issue. I think. I'm gonna look up what meromorphic means again. Because an infinite pole is an essential singularity. Is it not? Infinity bands near the South Pole. Two problems with poles at once. We're gonna EVR, yeah. Cotangent pi z. Uh I guess I don't know what I'm talking about then. Okay. So we can make holomorphic. And so I do know you can get some weird, like you can engineer a function that has like a circle for like a region where it blows up. So I guess we're just, meromorphic is not stuff like that. I thought it was something else. Oh, yeah, okay, so essential singularities do mean it can't be meromorphic? Yeah. Wait, it is. Oh my god. I hate math sometimes. Output logic, thank you for the follow. This is stupid. Like, what? Come on, man. Okay. Uh, yeah, I mean, I did, but it was an applied class, so we barely talked about meromorphic functions. But I mean, I guess it's true, Papadoria. I really hate it though. This is like the time I found out the hard way that 1 over x is a continuous function. But as long as you eliminate 0 as like from your domain, it's considered continuous after that. So I was trying to use it as a counterexample, and it wasn't working for the life of me, and turns out that was why. Technically true, but annoying. Yeah, yeah. It's like, um, why do they find it specifically with poles when you could just say isolated singularity? You have a chance to sign up for pure math courses. I probably could have. I wouldn't have wanted to. The like signing up for a pure math grad class sounds kind of scary for me because I'm not very good at pure math. The accumulation point example, is that somewhere on this page, or are you talking about some other example? Because it's a theorem. Oh, here it is. The function this is not meromorphic in the whole plane, so the point z equals 0 is an accumulation point of poles. Oh, you can get infinitely many poles near z equals 0. That's fun. Wait, but you could make this meromorphic if you eliminate 0, right? By the same logic? Yeah, surely you can. I'm saying you can. That's a Dawn certified conjecture. So what does that mean for this problem again? So I imagine for it to not be Ben, holy crap. How have you been doing, dude? Sort of burger #fitness. Oh my. I'm doing good too. Thank you. I just graduated my master's like a month ago. So I'm just relaxing now, applying to jobs. As yours switched to pure math? Is that like about to happen this coming school year? Or is that already happened? Thank you, thank you. Summer? Okay, okay. Oh my, I forgot. Sorry. Yeah. You've been switching, yeah, because it was engineering and then pure, and now it's applied. Well, hey, good luck though. Did I work on a thesis? I had the option to. I did not. I would have meant extending my time there because the entire program is just 1 year, and doing a thesis in just 1 year is difficult. And spending more time there means spending a lot more money on tuition. Finding the middle way, respect, yeah. And I just didn't feel the urge to do a thesis. Really, it would be a good idea if I was seriously going for a PhD in the future. But I'm just gonna do without it. My degree is stressful enough without doing a thesis. Your pre-math course, you don't even take exams. You just need to attend and ask questions. I don't think that's true. At least not at. There's no way that's gonna be true in my experience, at least. For real, CPX and algebra. Perhaps something special. We started 300 people. That's right. Yeah. It's coming back to me now. The last time we talked about it, like how brutal the pure math program is there. Yeah, I've heard that America is kind of unique in not caring about theses as much. And like if you were an American applying outside of America, they would ask to see your thesis, and a good amount of Americans wouldn't have one to show. Um like we don't care about theses because we pay, you mean, Ben? So you get more freedom? Oh, maybe. I never made that connection. I honestly I don't know. I know that a lot of countries do degrees very differently, and I just assumed it was some tradition thing. Like whatever, we just don't have that tradition. I don't know the specific reason why. Plan to write a thesis the upcoming semester. If you pass quals, you get the MS anyway. You want to do a thesis for PhD? Fair enough. 2 or 3 places here that give you the option of taking PhD only courses instead of writing a thesis. Oh, so I did do that. I did take PhD level courses, but those are not required. You could do the easier courses and still get the same degree. Their quals, you get a lot of freedom. Yeah, I think so. You get good grades on the 2 PhD courses. You don't need to write a thesis. That's a good compromise. Not sure such a function exists. Apparently, one of my students has a solution. Really? Yeah, it's an interesting question, Papadoria. I don't know how the kernel thing influences it either. Yeah, that's a really out there question. How does a PhD course work? At least in Denmark, if you're doing a PhD, it's just researching something new. Yeah, so Europe does PhDs very differently, as I understand it. Like in most countries in Europe, when you apply for a PhD, you should already have a master's and you should already have an idea of what project you want to do. Whereas in America, you don't actually need a master's. Usually, like a PhD is only 3 years in Europe, typically. Whereas a PhD in America is usually 5 years because you do the master stuff along the way. So you usually spend the first 2 years doing courses and then the last 3 years doing actual PhD work. So here, like the PhD level courses are basically just your standard graduate courses that you're expected to do as a PhD student before you actually do your real work. But yeah, there's like a hack in America where if you want a master's degree but you don't want to pay for it, typically PhDs are funded, so you don't pay tuition for a PhD, but you do usually pay tuition for a master's. So if you can get through the harder application process, you could apply for a PhD, get in for a PhD, which you would then get paid instead of having to pay tuition. And then after the first 2 years, you can take your master's and just get out. And you've gotten a master's for free. Do you feel you got hireable skills during your MS? I think so. We'll have to see if I actually get hired somewhere. But, like, I learned about machine learning, and that's a pretty hireable skill, I think. The math stuff in my uni is kind of... I mean, it is unfortunate. Like, the differential equations I learned, I don't think is very hireable. And I really wish it was, but I don't think there's a lot of regular salary jobs that involve doing differential equations. I think it's like PhD consulting type of work. Math in my uni is kind of unique. I've been taking courses with masters and PhD folks since like my second semester of undergrad. Oh, wow. Yeah, that is unique. Hey, Roxra. You liked my undergrad, it's somewhat different compared to other programs. That sounds advanced, Dionetta. It's like, it's not too uncommon for undergrads to take graduate courses here, but that's normally like a final year, maybe the year before kind of thing for undergrads. You wish you went to university, let me do that. My university had dynamics of ring theory as the most advanced courses. Oh, okay. In Denmark, you get full wages if you're doing a PhD. No, it's really rare you pay for a PhD in America. It is possible, but it's very rare. Normally you do get paid. It's not like a super cushy pay, but you do get paid here. You are expected to do TA work and stuff in return, but yeah. It's only masters that you pay for. Unless you're a PhD student and you get the masters along the way. I see why the kernel is there, because if it was just a function, the new G functions would just be non-continuous functions that are 0 everywhere, then jumps at the poles. Oh, sure. Taking the residue of these discrete functions are just 0. Yeah, okay, yeah, fair enough, Papadoria. I was being a physical sciences chair, he kept having to tell me, no, you can't do that, and it kept bugging him. My university's right now taking courses with junior undergrad students. Yeah, I did that too during my master's. Like, my math biology courses had undergrads in them. And as a graduate student, I kind of didn't like it because I felt like the classes were being slowed down because of that. But, oh well. What are you going to do? PhD students in the US typically earn a tax-liable stipend rather than traditional salary. Yeah. So it's not much, but it's enough to get by, I think. More than 25K side, probably. Also paid to do math since undergrad. That would be nice. Saw some guys debating on a live by say whether 0 to 0 is undefined or if it equals 1. Well, 0 to 0 itself is undefined, but in the limit sense, it's 1. Well, even that's not necessarily even true. You can have, like, 0 to the 0 can have different types. Like, yeah, as Papadoria says. So if you have the limit as x goes to 0 of x to the x, that does equal 1. But I could say x to the x squared. And this x squared goes to 0 faster than this x squared. Or sorry, faster than the x. Does that actually do anything? Do I need to put the squared on the other one? Or... shit. There should be a good example of this where you get a different result for the limit. Maybe if I said X squared to the x? That's just x to the 2x, though. I want the base to go to 0 faster, so the limit results in 0. I guess that works, Fembox, yeah. You could have the limit of x to the 0 as it goes to 0, which is 1. I guess that's the easiest thing to do, yeah. Just actually plug in 0 for one of them. Certain companies will also pay for a master's. Downside was I wasn't able to pick the topic because I had to be related to my work. Yeah, that's fair enough for the company's perspective too, but it does kind of suck. Yeah, and so I was surprised, but at University of Washington, it actually is possible to be funded for a master's, and I've never heard of any other funded masters in America before. But yeah, there were a group of students who like didn't have to pay tuition. Or so you haven't had to pay for your education at all so far? Yeah, but you're in high school. Undergrad students are more advanced than I was in undergrad. With some more differential geometry pros. It's so intimidating when you see the students who are like way ahead of their coursework like that. Yeah. But what did Papadoria cook up? Limit as x goes to 0 of x to the 1 over ln x. You think it's e? I guess we gotta do the old e to the ln trick. Wait, is it really like this? Huh. I guess it is. Yeah, that's a crazy limit, Papadoria. It just cancels out. Yeah, that's a fun one. I thought like 0 or 1 would be the only possible answers, but no. I mean, I was looking for one with infinity, but e to the 1 equals e. I am amazed that e to the 1 equals e. Yeah. Fair students feel like I lack some basic skills, so I have to take advanced stuff early on. Truly feel weak when it comes to some hands-on stuff. But my fault though, I was always lazy. I don't know. It's also possible other students are looking at you in the same way though, Yonetta, because there are definitely times in class where I feel like I'm the smart one who already understands what's happening in class, and then there's other times where I feel like I'm the stupid one and everyone else understands it. So I think it's hard to just objectively evaluate yourself. I heard differentiation technique. I guess product rule because it's so helpful. I don't like the chain rule because it gets annoying. Roxer, is this what the integral is? Like this? Or does the square root go over everything? Most of my colleagues are pretty good Math Olympiad guys. That's correct? Okay. So went to the IMO type comps. So most professors felt comfortable skipping some steps, which is reasonable. I don't really care for some of those. Probably never got to learn them properly. Oh, okay. Yeah, Olympiad, that's a whole different thing. Chain rule is not a bad call. I don't like... I stop liking the chain rule when multivariable gets involved. The product rule is cool because it's helpful in differential equation. It's the basis for integration by parts. Integration by parts is awesome, so... Yeah, I think I like Papadoria's idea. This is one of those ones where you just kind of randomly do u equals root x, and it'll happen to work out, probably. So let's do that. Wait, Roxor, do you know about U subs? Have we talked about those, or have you learned about them independently? 2 root x x+1 du. Then I'll switch all of these x's out for u's. Okay. So as long as you know, like, that was 3 months ago? Okay. That's gonna be arctan? Okay. Oh yeah, I can see that. Yeah. Professors was the first in my country to win a perfect IMO gold. Wow. All the exams were Olympiad-like. His courses were great, so it was kind of worth it. That's crazy. So yeah, Roxer, when you do a U sub, you have to, like, I mean, hopefully you're following along with this U sub. I said that U equals root x. I took the derivative of each side to say du is 1 over 2 root x dx. And then I multiplied the 2 root x to the other side. So 2 root x du is equal to dx. And so this dx became this du. Okay, good. And then actually, so these would both become u's here, but they actually just cancel before we even substitute. So let's just get rid of them. The 2 can come outside. And so, if u is root x, then u squared is x. So this x becomes u squared plus 1 du. Wait until bros hear about the definition of differentiability in multi-dimensions. Having directional derivative defined in every direction is still not enough. Wait, is it not? Or do you mean like every linear direction, Papadoria? And then you just have to recognize this is the as arctan, basically. Or inverse tan, depending on what you prefer. Same thing as like tan inverse. Yeah, unfortunately. So if you know the derivative of arctan is 1 over x squared plus 1, you have to recognize the like reverse of it here with integrals. Unfortunately. We do need a plus c also. Unfortunately, yes, Roxra. Hey, GrioD Gaming. And then just undo the sub, and then the problem is done. Oh, you said a directional derivative in every direction. Right, and the directional derivative is inherently, like, linear. Yeah. No worries, Roxra. Your old Bulgarian professor was a math teacher for him. Many students went to IMO. No. You know where you'll apply in my PhD? Those professors want me to leave my country, but I'm not staying for material. I mean, it doesn't hurt to apply for a reach school, though, Yonetta. I wouldn't exclude yourself automatically. But like, grad school's a nice excuse just to travel and see the world. You don't have to apply to Stanford. You could apply to, like, less competitive places, too. Oh yeah, we can do that, GrioD. We actually just doing roots of unity earlier. So you want all 3 answers for x when x cubed equals 8. And so we're going to let x be a complex number, re to the I theta. And so it's re to the I theta cubed equals 8. And we use exponent rules on the left side, r cube. That's not 3. Oh, by factoring? Okay, that is better, Femvox. I don't know which way GrioD would prefer to see it. Factoring is probably better. Okay, fine. Do it both ways? Okay. you want to see the factoring? Okay. I'll save this for after then. Theta, because I was going to use complex numbers, Roxra, and complex numbers have a polar form involving an angle theta. I can talk about it more after we get through this problem. Let me catch up with chat, and then I'll... So the factoring idea is, say, x cubed minus 8 equals 0, and then factor this. Let me just catch up with chat quickly, and then I'll do that. I'll be applying for every IV. There's 95% chance I get rejected from them all. It's still worth trying, yeah. But Professor is the most adamant about Milium country is the one that went to Courant. Okay. Nice thing about math is that the community is small, especially if you're interested in algebraic geometry. Fair enough. Geometry is evil. Okay, so I guess we'll just use a difference of 2 cubes. Kind of boring. I was gonna do synthetic division or regular division. Difference of 2 cubes is the better way to do it, though. So we get x minus 2 times x squared plus 2x plus 4 equals 0. Okay, yeah. Let's make sure I'm not missing a sign. Oh, and Rooks have got the same thing. Can you do all high school algebra with geometric methods? I mean, you probably could. I don't know exactly how, but something like that. Okay, so off the bat, we know either x minus 2 is 0, or x squared plus 2x plus 4 equals 0. So x equals 2 is one of the 3 answers. Femvox wants to complete the square. It's the same thing as doing the quadratic formula, though, so I'm just going to do the quadratic formula. So minus 2 plus or minus root b squared minus 4ac over 2a. 2i root 3 over 2, cancel the 2's, minus 1 plus or minus I root 3. Those peanuts. I mean, no, you can boo me if you want. Completing the square is just the quadratic formula. Why would I not just go straight to the quadratic formula? Yeah, I hope that helps, GrioD. Let me know if you have any questions about that. The home do math you did all year? Hell yeah. Funny thing is that I don't even know what I want to study. If I could study set theory all day, make some relevant contributions, I would. Most people, it's kind of a dead end. I'm considering either some topological or algebraic areas. Undergrad research advisor is a big name in dynamical systems, but I did my undergraduate research in degree theory and differential topology. Yeah, Yonetta, I don't have good advice to give you there, but I hope you find something that you like. Am I a fan of lemon tea? It's pretty good. Just complete the cube instead of Cardano's method. So just scuffed way of finding roots. Your initial complex analysis attempt was better. Should look at how to really lift, bro. No, like, depending what math class you're in, this is the more principled way of doing it. Like, rational root theorem, divide out the root, yada, 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 resident sleeper. I prefer the complex analysis way too, though. And I'll do it just for fun right after this anyway. Lucas, I have an actual question. How come people graph functions? Like, what's the purpose of it outside of knowing vaguely how the 20 most known functions look like? Well, because it gives you intuition for how functions behave. Also, by the way, guys, Lucas streams, if you didn't know. And I believe has done at least one physics stream, and maybe there's more to come. But yeah, like graphing functions gives you intuition for how they behave. So I guess there isn't a purpose strictly within math beyond knowing how functions look. There's definitely more to come. Awesome. If you want to talk about like applying math, like I think, and like data, then I think it's a lot more obvious why it's helpful to graph functions. But just like strictly within math, not thinking about applications, knowing how a function looks is really powerful and really important. So I've been drinking so good, nice. Oh yeah, Rookster, I will do it. And it's important to know how they behave, because when you get some more complicated functions, and you can express them as like, oh, it's sort of like a quadratic or sort of like a sinusoid or something. Ricardo's method depressing the equation? I think it is, yeah. Drive a carriage to work as well. A circle doesn't mean better. Give the kids greater burden so that they be strong like us. Coolest thing about complex geometry is that the country of origin of my family is quite strong complex geometry. Oh, cool. Your brain had a dozen Wolfram Alpha as a plugin. I mean, you can kind of build that up over time. How's I use an application since no two numbers multiplied together can equal a negative number? Ludwig, I think like electrical engineers use it a lot. It's really good at expressing rotations and things that are periodic. And so like a Fourier series is, Ludwig is in the YouTube chat. You'll be able to see him up there. Fourier series are a huge idea that are really super applied, and those rely on complex numbers. You can talk about a lot of two-dimensional things through the language of complex numbers, even though it isn't physical. So like fluid dynamics, you can express that with a complex function, like how a fluid flows at each point. Griody, I see that problem. That looks like a pain in the ass. I think I'd rather not do that problem. I do want to show the complex number way. I'm just trying to catch up with chat. E to the tan 1 over x. I actually, if I tried hard enough, Max Sylvester, I think I could do that. I just have to. I think we probably good like 5 or 10 minutes of just like concentrating though. One thing I've learned from my stream, Elris, I think I learned, is that a physics unit has to be expressed in at least one other unit. So if there's time left of the equal sign, there has to be at least one vector of time. Yeah, like if you know a problem has to like end up with newtons, you know, on the other side of the equation, if you have like time here, it needs to cancel out with some time on the bottom or something, or it needs to get packaged up into whatever becomes newtons. So like dimensional analysis is huge in physics. It's really helpful. What's the intuitional notion you're most proud about? I'd have to think about it. Let me do the complex number thing. Mass stream greater than DayZ stream, that's a linear order. I mean, I like doing both. Okay, so Rockstar, I assume you know like a complex number exists. Like we can talk about 2 plus 3i, and we can have a real axis and an imaginary axis. And 2 plus 3i would be 2 to the right and 3 up, right there, right here. Now, complex numbers, this is like the Cartesian form of a complex number, or rectangular forms sometimes. But it turns out you can actually express complex numbers with different coordinates, with polar coordinates. So instead of a direction along the x and a direction along the y, we can talk about a radius from the origin and an angle theta. And if you notice, we get a nice little right triangle here. So we can convert between these two coordinate systems using trig. Oops. So, we can also, I should have chosen a better example than 2 and 3, but you can say it's completely equal to, the polar form of a complex number looks like re to the I theta, where r is the radius, theta is the angle. And if this looks weird, it's because it is weird. It turns out these two things are completely equivalent if you find the right r and theta. R is equal to root x squared plus, or I guess a squared plus b squared, if we want to go with like a plus bi, ib, I guess. Notation. And theta is arctan b over a, but you may have to shift around depending on the quadrant. And the reason, it's getting a little bit too extra, but the reason this works is because of what's called Euler's identity. E to the I theta is cosine theta plus I sine theta. And this gives you the conversion from polar back to rectangular. That's not too important for what we're doing right now, though. So I'm just trying to say, the only thing I'm trying to say right now is that complex numbers have a polar form, and it's the exact same thing as our regular Cartesian coordinates, just expressed in a different way. And sometimes this expression is more convenient. Like for the problem that we're about to do, with x cubed equals 8. So if we let x be a complex number, we can write it as something re to the I theta, where we want to solve for r and theta. So plugging in our definition for x, re to the I theta cubed is equal to 8. We can use exponent laws on this, so r gets cubed, e to the I theta gets cubed. R cubed e to the 3I theta is equal to 8. And then we can do a sneaky thing. Remembering that 8 is technically a complex number also, I can multiply it by e to the 2I pi, aka Zach. This is equal to 1, and you're allowed to multiply by 1. And then what I like to do is, I know that this r cubed needs to equal this 8, and this e to the 3I theta needs to equal e to the 2I pi. So I can just equate the things that I know should be equal. So r cubed equals 8, e to the 3I theta is equal to e to the 2I pi. And so from this, we just get r equals 2. From this, I'm going to equate the exponents, or you can take the ln of each side if you prefer that idea. Oh, I lied. We need a k, where k is an integer. Zach is hidden inside of this, but so it's still equal to 1. Yeah, I forgot. We do need a k though, because there's going to be multiple answers. And I'm falling behind on chat. I promise I'll catch up with chat in a minute. So 2I pi k. And then we just solve this for theta. So divide by 3I, and we get 2/3 pi k, where k is an integer. Right, as Penn says. So we don't have infinitely many answers, as it turns out, because oh god, how do I explain this? we're only gonna have 3 distinct answers, as it turns out, because we started with x cubed. We're gonna have 3 unique roots, and so the k's that we're going to take, you could take other choices of k, but the simplest one is k equals 0, 1, and 2. We'll give you the distinct answers. And I can't explain that. It's just going to get a little bit. We're going to have to get even deeper into what complex numbers mean. But if you go with me for now, this means our 3 answers are always equals 2, and we have 3 choices for theta. So we get x equals 2e to the I times 0, which that just becomes 2. That's a terrible bracket. 2e to the I 2 pi over 3, and 2e to the I 4 pi over 3. And these are your 2 complex answers, which we could convert back, and they will match these complex numbers we got here if we put them back into rectangular form. Okay, I'm going to scroll up in chat and catch up with the things that I missed. Complex number satisfies triangle inequality in Cauchy-Schwarz. It does. Like Ohm's law, ultimately units on both sides of the equation have to come out equal. No, the volt equal to an ampere times an ohms. Yeah, I bet there's like a better example. I guess F equals MA would even work. Cosine is also just like, how wide is this part of the circle? Sine is how tall is this part of the circle? Yeah. Coordinates in circle form, basically. Oh, and Felix already thought of F equals MA. Form is how you derive theorems in complex. People decide to be fancy and say it's F of Z. Right, they're fancy. Zach is a cheat code. WC 3rd versus 4th is 3-4 for England. Ooh, a high-scoring soccer/football game? Wow. You have an equation, the units on both sides that come out equal, right? The way your team I root for has to lose miserably. I should apply to Penn's College? I mean, that'd be pretty cool. From Euler, you can describe Z cubed as dilation plus rotation. Thinking about geometrically, right. That's a really fun way of looking at complex numbers. Looking forward to math professors. Remember it, but I mean, I can sort of do that. I only know basic machine learning. One was defined as a force that accelerates. Right. Pie in the sky. Welcome in. What is the mechanical intuition behind I? That's a really good question that I don't have a great answer for. I think of I as a convenience thing. We technically don't need it, but it's often the best way to think about certain types of problems. And those types of problems are usually when rotations are involved or any sort of periodic motion is a mechanical intuition. And as Penzner says, like, just I itself is a rotation by 90 degrees. What complex numbers are great at is succinctly talking about rotations. And that's like the mechanical intuition, I would say, where if you have like a mass oscillating on a spring, this is periodic motion. You could talk about this up and down motion with complex numbers if you wanted to. You wouldn't have to, but you could. And so where they come up and are really helpful is if you have a signal, like imagine like the sound wave for a song, it should be more jagged than that, right? Some really crazy wave is what I'm trying to create here. You can use complex analysis in I to break this down into like fundamental waves that sum up to this final music wave. That's called a Fourier series. And I'm not doing a good job of explaining it, but yeah, Roxra. But I was trying to give an example of where complex numbers are helpful for things that involve like waves. Oh, yeah, Dustin, I sort of know the connection between linear algebra and complex analysis. I'm still kind of fuzzy on. I've had someone explain it to me before, and I've forgotten. It's been too long. But there's a rotation matrix thing too. You get behind that instead of someone saying the intuition behind is first. Not gonna lie. France England is 3-5. Wow. It's unclear what's rotating. Right, because it like any sort of periodic thing is related to rotations, even if it's kind of weird, and I don't fully understand it for myself. But sine waves, for example, are related to circles. Like there's a thing called a generating circle for a sine wave and a cosine wave. Yeah, this is the thing. Like, I know it's true. I don't have a good intuitive explanation for it though. So, like, Pie in Sky, you deserve a better explanation than what I'm giving you. But I can tell you that there is a connection with periodic motion and rotations. I don't have a way that I love of describing it. If I don't understand the intuition of why a formula is set up, I could also just accept if someone says this is defined because it's just handy. See it in other equations. If I do understand the intuition behind those other equations, then I think I do understand intuition, somebody's just yapping a lot. I'll talk about just chatting with the frequency of messages. Think of it as vectors rotating. Yeah, you can do that for sure. What are we doing syntax? We've kind of gone down a complex number, just like the intuition for rotations rabbit hole. Pie in the Sky was asking, like, what is the intuition for the mechanical intuition of I, basically? Is what I'm trying to answer, not doing a good job of. You can't pronounce Mbappe's name. So I was cheering for England. You have usual rotation for that with trig. Yeah, and the point of complex numbers is that it's way more compact. Instead of the beauty of complex numbers is they look like a scalar. So we can just talk about like one variable z, whereas if you stuck only to trig, you'd have to talk about f of x comma y. And you can do that, it's just the theory is much more complicated. And as it turns out, for complex numbers, a lot of the single variable calculus things that you want still hold true. And so it's just much easier to talk about complex numbers than it is to talk about a multivariable thing. Complex numbers are inherently multivariable, but you get to not think about it a lot of the time, which is what makes them so cool. So, yeah, Pine Sky, that's why it's a convenience thing, is how I think of it. You don't need it, but you do want it. Moscow's a very smoky puzzle to solve right now, aren't you? Probably. Because I follow you, so if you stream physics, probably drop by and annoy you. There's the most beautiful stuff in the universe. Fair enough. Actually, so for example, the reason I have bad physics intuition is because the force of an object is never just mass times acceleration. Acceleration is influenced by that is still mass times acceleration. It's just acceleration depends on time now, Lucas. Because that's when you get like a differential equation. Sine of I, yeah, we can talk about sine of I. Oh, you diagonalize the rotation matrix, right? That's the connection. If you want to evaluate sine of I, how do you do that again? I mean, sine of I is just sine of I. It's just, well, why don't I remember this? So, I mean, I know we could call it the imaginary part of e to the I, but that I don't know if that's helpful. Goes into roots, loses on branches though. I should have trig to I is like an integral to sigma. Sorta. I don't know if that's how I would think of it. Real complex numbers isomorphic to matrices 2 by 2 of the form a, b, b minus a. Yeah, there's a really good connection between linear algebra and complex analysis. I'm just a little bit rusty on it. Max Webster thinks it's a minus b, b, a, because 1 is the identity matrix. Maybe. Right! Thank you! Syntax, I don't know why I okay, yeah. The complex... For complex numbers, the definition of sine is e to the iz minus e to the minus iz over 2I. Thank you. I'm getting tired, I guess. It's been 4 hours. Why is e here? It's because of, again, of Euler's identity, actually. E to the I theta is, oh my god, cosine theta plus I sine theta. And we also know e to the minus I theta is cosine theta plus I sine theta. And if you want to get a complex definition of sine, you can like add, oops, sorry, minus. You can I guess subtract these two equations. Two I sine theta. This is for a real number. Did I say this is wrong? Does he have to be a real... Oh, I just googled sin. Sign. Forgive me, Father, for I have signed. Signed what, exactly? I made an oopsie. It's not... Okay. Sine of z has a definition, though, doesn't it? Oh, it's just... Okay. Fine. I shouldn't have said z. I should have said theta. Or x. But then, if we have I... Okay, I fell behind on chat again. Do I have I? Ugh. You remember Googling complex anal trying to learn more, but what I found wasn't helpful. So the thing is, this definition of sine, it's not helpful for sine of I. That's why I was struggling, I guess. So we're really trying to figure out what sine of I is. We can talk about it in terms of sinh, though. ETX is just a fancy way to write down series. I mean, yeah, everything comes down to a power series if you wanted to. 6-4, wow. Sine what? I'm just making a joke about the sine function. Math should be banned because of the many sins or cosins to cancel it out. I do think it should be banned because of the sins. Here's your sine. Yeah, it looks like a cool stream. I should watch it. Fair enough. Couple people with buck teeth. I know 3 Blue 1 Brown has a video about this. Ah! I just knocked my pen over. I have to grab it. 3 Blue 1 Brown. Euler identity. A poem. This is the one that I was thinking of. I guess he has a bunch. But this will probably do a better job of explaining it than I can. We'll keep on talking about it. Destin, I'll look at that later. Let me grab my thing. Ugh. So, okay, this definition of sine is only for real numbers is the issue. And the original question was sine of I. Which means we need to do the power series. Which I'm just gonna look at. We would want this. Like this identity. Sine of z is equal to minus I sinh iz. That you can show using power series. Because this is a cool thing, but it's only for real numbers. And so if you want to know what sine of I is, you have minus I sinh of -1, which that's just a number. Is that a clean number? It probably isn't a clean number. Yeah, I don't know. Oh, and sinh is an odd function, so you can say sine of I is equal to I sinh of 1. Wait, this formula, does it work for all complex numbers? I feel like it shouldn't. What was the proof for Euler's formula again? Do you know me a shaded proof like a Taylor series? I don't know. I don't have a satisfying proof for Euler. But Leo, what, like, this technique doesn't, it's only works for real numbers. Question is a cinch? Like, because Euler's identity only works for real theta. Because apology semester, e to the x was visualized as a spiral that looks like a lift. Probably because it is one. Huh. Well, okay. Oh. If you have e to the iz, you need to say that z is r e to the I theta. Or sorry. I guess you need to do a real part and imaginary part. So e to the minus b, e to the ia. And then on this part, you do Euler's. So like you can do it, but you like it's not. It's like it indirect. Like that's what I'm talking about. And so maybe you can do that, and you get some nice thing that you can factor out front or something. Then complex numbers by adding re to the I theta. Shoot, I don't know what it is anymore. I guess for Euler's formula. You know, sine of x equals the thing on the reals. Cosine of sine is an entire function. No, the form works on all complex numbers. Oh, I guess that's fair. I don't know. I guess I'm rusting my complex analysis. I thought that only worked for real x. I guess not. Yeah, I do remember that now, Leo. Where's my resize tool? There it is. All right, this is what Destin sent about the connection between matrices and complex numbers. Starting off with a polynomial for some reason. Find a linear operator. Is that linear? Choose a basis. Okay, I have no clue what any of this stuff means up here. I have seen this before, that you can talk about the matrix that squares to the identity as being basically the same thing as I. I do know if you square that, you get like just your good old identity. So I have some f equals g on some reasonable enough set. Yeah, I remember that sounds right, Leo. Like an analytic continuation. Um, I to the nth sine of idea. Now you're just memeing on me, Roxra. Sounds like because you said it in your Leo lectures. That's true. Okay, so Lucas did ask earlier about the proof for Euler's formula. I don't have a satisfying proof for it. The closest thing that I know is the power series thing, but even then, I don't really like it. I've seen this proof with derivatives before. It's not that satisfying either. This way might be nicer. I don't know. It's you still kind of pull e to the ix out of your ass though. That's what I don't like about all these proofs, where you like none of them feel very organic. The only somewhat real proof is the Taylor series. Yeah, Lucas, I agree. Real change predicts present sign customer exponential functions the whole time. Yeah. And this, yeah, and you see the similarity between sine and sinh and cos and cosh. Yeah, Lucas, I might say to look at 3 Wheeler and Brown's like videos on Euler's formula, because I'd never like it's nice to look at, it's easy on the eyes, but I don't understand it. Like I don't know. I just accept it, but I don't like why it's true. How do you find a Taylor series for a function? There's a formula for it involving the derivatives. So like you normally find the Taylor series around 0. And so like the first term is just the function evaluated at 0. The second term is the first derivative evaluated at 0. Then the second derivative evaluated at 0 divided by 2, and so on. I can, okay, sure. Let me just show it rather. That's probably that. Yeah, it's probably a bad thing to explain with words, isn't it? Trevor says I smell bad. Wait, who's Trevor? Explain with an interpretive dance. One of your 4,000 kids. Well, Trevor's right. I do smell bad. You got a smart kid, but also high. So Lucas, it's just I would look at this one for the Maclaurin series. It's just a formula basically. Whenever I have time for this integral, Roxra. Let me show what Roxra just sent. I don't know if there's enough time before the heat death of the universe for me to solve that integral. We have a Bessel function of the I root tooth kind? Is that even... I never... Well, hey, at least we're integrating over the unit circle. That's nice. Think you're daydreaming again? Where do you start? Well, I guess you do have this inside problem here that you would start with. The real good start is to delete this problem from your memory. All right. Good night, Yonetta. Thank you for hanging out. You got another sub problem here? Is the answer 0? Oh, just imagine it's analytic. I don't know how you would tell. Yeah, exactly that, Lucas. It's always a polynomial. You know what the bounds really even mean? Yeah, the z not equal to plus or minus I is kind of unnerving. Like, what are we really integrating over? I assume it's like a principal value type of thing, where you're just getting infinite, like arbitrarily close to plus and minus I, but not actually touching it. Yeah, it must be principal value, right? I don't know. The intuition behind Taylor series is that requiring expansion of a function f is used to make the as an infinite polynomial p. Yeah. It has no finite answer. Great. Where did you get this from? This is like some monstrosity Wolfram Alpha would give you when you plugged in your problem wrong. You know what Taylor series are? You're just trying to freshen up a bit. Yeah, like if you want to do the Taylor like series for sine of x about 0, like your first term is just sine of 0. And then it's plus a derivative of sine, which is just cosine, evaluated at 0 times x. And then take the derivative of that again. It's minus sine of 0, but now you divide by 2 factorial times x squared. So you just take derivatives and plug in numbers. It's piss easy. Yeah. Taylor series are a fantastic, miraculous thing. I mean, if you want to have it not be easy, there are functions that don't have Taylor series. So like a fun one to do is try to Taylor expand e to the minus 1 over x squared about x equals 0. It technically has a Taylor series, but it gives you the wrong answer. My face does not have a Taylor series. That's correct, Leo. Actual problem sent? I don't want to do this. This is a monster. Owned. Mm-hmm. You're unsure how to prove it. It's kind of like a limit proof. If we go back to the example with sine of x, you would consider the difference of sine of x minus its Taylor series. I don't know. You either want big N or infinity there. I guess big N. Minus 1 to the N. I might get this slightly wrong. It's not really too important what the actual series is, but you would bound this above, maybe strictly, by some number that you show gets like infinitesimally small as N increases. That's the idea behind proving why a Taylor series converges to like an actual function. Yeah, it's just an extension of like an epsilon delta type of proof. For better or for worse. It's probably equivalent if you can show that this is equal to 0, that's also good enough. It's probably just I bet the proof would be easier mechanically if you don't go to infinity, you just go to n that's very large though. Like you work just with big N, and then at the very end you let it go to infinity, is what I'm trying to say. Yeah. Yeah, I guess I should have written. I mean, I wouldn't take the limit until the very end. I would start by working with this because this is There's a thing called Taylor's remainder theorem, or just Taylor's theorem, that talks about the kind of like this difference you could call a remainder or the error. This is getting into like asymptotic analysis, which is a pretty fun topic. This is saying it, but it's not as clean as I want it to. Yeah, I forgot this Wikipedia page. I always have a hard time with it. Basically you can find expressions for the error that the series has and show that the error goes to 0 as you have infinitely many terms. Favorite analysis operator? Probably a Fourier transform. Partial derivative type of function out of the Taylor correction function. I don't know about partial derivatives. Maybe, but I don't know. Roxer, this integral that you've given me is... It looks terrible. I don't want to do it. It's going to take forever to do this last term. The first 3 terms are not bad at all. Do you have any poles? I guess you don't have any poles. That's a nice thing. You fuck with the Lagrange form of the remainder? It is really helpful. Without loss of generality, integrate the 4th term. That's how a pure math edition would do it for sure. Okay, I'm not sure why you're asking this, but... Oh yeah, it does kind of look like a quotient rule, doesn't it? I guess we can do this one. I think I'm going to wrap up the stream after this, though, because I'm starving. Okay, the first term, you just slap an x on it because it's a constant. This term is always tricky. It's minus cosine. This term, divide out the 2i. There's an I in front, so that cancels. 1/2 e to the 2ix. Divide from 0 to pi. So you get 64. Cosine of pi minus 1. 1. Is this going to be 69? Zero minus 3/2 plus 1/2. Oh, okay, yeah. So we get 64 plus 3, right? So we get 6, 7. Great problem, Roxra. Oh, wait. Actually, I think this is just a u sub, maybe. You just take u equals to 1 plus I cosine x. Well, no, never mind. Never mind. They both equal 6, 7? Oh, I guess the last part is 0? Maybe there's a way you can show that. I like a mathematical thing that shows the correction term for x equals a and for a function f, if that makes sense. I think you have a math thingy where you first find the function, then Find the x in that function for the formula for finding that. There's a lot of for the functions in that sentence. I equals -1 over I. Yeah, like it's kind of weird that that's true syntax, but it is. Gaussian integers reference. Fair enough. Number classification N, Z, Q, R, C, H, O. I guess C. Complex numbers are pretty cool. It was a backwards quotient rule after all. If I wasn't like 4.5 hours into math stream, maybe I could have figured that out. I really want to call it. I'm starving. And I'm tired. Thank you for being here, and thank you for the questions, though. The YouTube will get cut off here. On Twitch, we'll look for a raid. And was here on YouTube. Thank you for being here.